Um, Nicholas, do you celebrate yesterday or no? What do you guys do? Hot pot? Mm. So a traditional Chinese food is hot pot. Um, I don't know if they have a hot pot restaurant around here. They do on Kirkman. Kirkman called Night Drag. It's not something nice spicy or nice spice. Is it fashion? Yeah. So it's basically a hot pot. You put all kind of meat, foods. It's like a all kind of food that you can put in. You can put anything you want, vegetables and stuff like that. So yeah, hot pot is a very traditional for New Year, and yeah, that's one of the things that I do. Um, the Japanese celebrate Chinese New Year or no? That's Japanese has its own thing or no? Oh, okay, yeah. So yeah, you guys are boring. Just kidding. Um, so we're gonna talk about a couple things about logarithms and how to solve log equations and stuff like that. So first of all, I want to teach you that say how to solve a log equation.
It's not projecting.
Oh, it's not projecting, my bad. So I'm gonna do that. Projecting audio, new movie recording, and that may project on the other side. Office. Is it projecting?
Yeah.
Okay. So let's just talk about let's talk about a proof of understanding about why exponential form are the exponential form and the logarithm form are inverse to each other. Um, so first of all, I say, what if I have a something that say y equal to 2x, right? So y equal to 2x. And what's the inverse function look like? Well, inverse function look like is basically, in order to find inverse, you switch the x and y. Do you guys remember this? But the problem is, how do I get y by itself? How do I get y by itself here? Because you have to solve for y. Usually, you find inverse, you have to solve for y. So how do I get y by itself? Yes, Kate. Exactly, because that rule, the third rule says that the third rule says if you do natural log of x, and I do natural log just because I prefer natural log over log, a 2 to the y. This is the only time you can bring the power down. The ability to bring the power down is only on mathematical function, only the logarithms. Because the third property that we went over yesterday. What was the other property? Which is natural log x plus natural log of y equal to natural log of x times y. Natural log of x minus natural log of y is equal to natural log of x over y. But not this two property. It's actually this one. Natural log of x of y is equal to natural log of x y, like this, x to the y power. And also the last one, remember the last one is if you have log of b of m is equal to natural log m over natural log of b. So we are focusing on these two things. Why is that third property is really popular? Because that third property actually the only thing can bring the power down to the things. So if you bring the power down, what would it get? Natural log of x equal to y natural log of 2. And then you can solve for that. So it's y equal to natural log of x over natural log of 2. Now, due to this property, I can actually change that. I can change that to log 2 of x. And this becomes the inverse functions. that becomes the inverse function. F inverse of x equal to log 2 of x. It's all the Chinese New Year text message. Sorry, turn it off. Does that make sense? That's why that y equal to 2x and log 2x are inverse to each other. Are we okay here? So we're just proving that they are inverse to each other. Okay, so what's the nice thing is that if you understand this stuff, then you can understand, you can talk to people when they say, what is log? I remember the first year I taught Algebra 2, I teach log the whole session. A lot of students are really confused at the end. And so one student, like one of the good students asked me, so Mr. Ye, what does log mean? And honestly, that was my first year of teaching. In first year of teaching, you usually have no clue what you're doing. So they were asking, like, what does log mean? And I'm like, honestly, in my head, I said, I don't know, right? But I cannot show them I don't know. I'm like, I already teach you a whole week. How come you still don't know, right? So I play it off like, instead of like admit like I have problem, I kind of blame the problem to other people. Very horrible thing to do. Very horrible thing to do. But the thing is, like if you're teaching, you really cannot show your weakness. If you show your weakness, your students can write over you. And I know that the first year of teaching, and I can't really show them my weakness. So I have to say like, no, it's your fault. You don't know what log is. I teach you whole weeks. So I kind of make fun of her. But anyway, the really bad person of me, I have to admit this day that that wasn't the right thing to do. But I should have told him I actually don't know. I need to look it up and I need to tell you a better way. So basically, this is the questions for her, because to admit my mistake in the past. So therefore, if anybody ever asks you what is log, you can say they are the inverse of the exponential functions. So like 10, and there's a 10 inverse, like a square root, there's a square. They're inverse to each other. If they're inverse to each other, so that's why that property of b log of b of x exists, because b and log b, they are gonna be inverse to each other. See, this is an exponential to the inverse. If it's exponential to the inverse, that's gonna be resolved with x. They will cancel out and get you x. Why that's important? Because you got some situations like this, you have to know. So there are two different type of equation that you need to learn how to solve. One is like, well, what is natural log of x? 2x plus 1 equal to 2. Like this. Now, I'm going to show you a two-way to do it. I prefer one way over the other. Okay, I prefer one way to the other. Now, I'm going to show you the way I prefer. Now, the way I don't prefer, I actually don't write this, but I will show you intermediate step what happened. So basically, natural log is log base e, right? Does that make sense? Log base e. But so what I'm going to do is I'm going to use this property right here, and I can e to the both sides. E to the both sides. Why do e to the both sides? Because e, remember, this is what? Log e, right? So this can cancel out. Does that make sense? But has to be raised to the power. You had to raise e raised to that power. So you basically make those becomes a exponent and e raised to that. Are you confusing here? It's okay? Okay, so then e and natural log gonna cancel out. So that's gonna be 2x plus 1 equal to e squared. Does that make sense? And the 2x equal to e squared minus 1. And the x equal to e squared minus 1 over 2. So that's how do you solve a natural log equations. Now you're gonna be like, oh no, this is so hard to understand. It's not. If with what we know yesterday, you could have done this way as well. You could have done this way with the hard method way, right? Guess what? E to the 2 equal to 2x plus 1. Same thing. Not my preferred, but it's still same thing. Why do I prefer that way? It's just because for me, I just kind of do it in my head. I just do e to the both sides, so I raise the power on both sides. So, and I think mathematically, it's makes more sense to, if you have square root, you use square to cancel, and not to use a other method. But however other method works, because sometimes, what if you don't remember that natural log is log base e? But you can always easily remember e to the natural log inverse each other, so you can e to the both sides. But that's just my preference. It doesn't mean it's a right way. I hate to say it's like you had to do things the right way. I don't know if you ever a math teacher told you you had to do it this way or no way. Have you done that? Have you seen those teachers? That you have to do it this way, right? I hate to do that to kids because I really think that sometimes students come up with way better explaining than me. I will actually use their way. So throughout my teaching, sometimes you think all the material I get it from teacher. Actually not true. Some material I got is actually learned from students, and I think students' way is better. So like a factoring by box, do I ask you you have to use a box? No, I just think it's a better way. Now, you don't use a box, you factor it your own way. I will not say anything against you. Right. For example, Caroline. She can factor it, fine. I'll leave her alone if she can factor it, right? It didn't matter. She used quadratic formulas. And it works for her. It's fine. I don't say because you use quadratic, I take points off. Did I do that to you? No, yeah. So it's fine. It's I think that's what I think that you kill the creativity if you told them says this is the only way you can do it. Well, it turns out math are super creative. It's super creative. Math is probably the single most creative subject in the world, believe it or not. Because the stuff they pull out, I will show you how to do integration of secant of x. The stuff they pull out from their brain, I don't know how they come out, like 400 years ago. Honestly, don't know. Does this make sense, how to do it? E to the both side. If you have natural log, e to the both side. Now, if you have e to the so let's say e to the x plus 1 equal to 5 like this. Now what do you do? How do you get rid of e? You do natural log both sides, but you don't raise the power now, right? So you're gonna do ln on both sides. You got to ln e to the x plus 1 is equal to ln of 5. So that is going to be cancel out x plus 1 equal to ln of 5, x equal to ln of 5 minus 1. So that's how to solve e equations, e to the equations. Now, you learned this in the past, but you probably just don't remember it. Any questions so far? Yes, no, maybe?
Do you want us to simplify any further from like ln of 5 or like e squared or anything like that?
No, ln of 5 is fine. E squared is fine. There's nothing you can simplify more. It's a constant, by the way. Okay. How much time I have? What time we get off? Right, over 15 minutes. We got enough time. We're gonna talk about one other question that you might have. Is this two question? Do I need to give you an example or you guys got it? It's not too bad, right? It's not too bad. Okay, so I'm gonna assume that you can do it, okay? Now, one other example that you might see on ACT, I want to go over this particular questions just because I think it's kind of important. So it was log of x plus log of x minus 3 is equal to 1. Okay, so this is probably the hardest ACT question that involves a log that they can give it to you. Now, I want to talk about this question with two reasons. One is understanding there's extraneous solutions in terms of logarithms. You guys remember what's extraneous solution earlier? It's the extra solution that's not needed and it's not fit in the domain. So extraneous solution is going to be kind of important for you guys to understand. Now, for e to the x and things like that, usually you don't have a extraneous solution, but this type of case, you will have extraneous solutions. So let's give it a try. So what do you guys think? How do I solve this problem? You have log of x plus log of x minus 3 is equal to 1. Yes. Okay, good. So what do you do? So you multiply this. Okay, so it's going to be log of x squared minus 3x equal to 1. So what do I do after that?
Aren't you gonna do like, so would it be like 10 to the power of 1 equals like x squared minus 3x?
Yes. So you can do a hard in this case, or you can do the other way. So that's going to be x squared equal to, it's going to be 10 to the 1 is equal to x squared minus 3x. Now remember, I don't prefer to do that. You can do whatever you want. I actually prefer this way. It just, I think I can see things a lot easier in the future. It's 10 to the 1, and those two cancel out, and that's the reason being. But it's x squared minus 3x minus 10 equal to 0, x minus 5, and x plus 2. X equal to 5, x equal to negative 2. And I have two answers. But there's only one correct answer. Which one would it be correct? Yes, Sarah? Five is the only right answer, and you cannot have 5. Log 2. Let's think about it. Why can I have negative 2, right? So let's say log of negative 2. And let's say this is 10, right? So think about 10 to the what power is going to give you negative 2? 10 to negative power doesn't even give you a negative number. Does that make sense? 10 to the positive number is getting really big. 10 to the negative number doesn't give you a negative number. So therefore, this is not a true statement if you have log of negative 2, log of negative 2. So log of anything negative is automatic extraneous. And that's why later on you're going to see that there's an absolute value around log when you do integrations. Any questions here? Yeah, the answer you got is negative 2. That's going to be extraneous because that's not needed. It's not important. Because you cannot see if you have log base of 10 negative 2 equal to x. 10 to the what power is equal to negative 2? It doesn't make sense. 10 to any power does not give you a negative. 10 to the negative 2 power is 1 over 100. Does not give you a negative. There's no negative option there. Second reason is natural log graph is like this, and logarithm graph look like that. There's no negative also. So domain restrictions that affecting the answers, you can only have positive answer for logarithms. That's the second reason. Are we okay? Okay. So what we're gonna do is teaching calculus. Right now I finished your pre-calc stuff, okay, and algebra 2 stuff, and then you start building a better foundation to move out from there. And then you say, okay, well, what's calculus? It end up calculus is much simpler than pre-calculus. Calculus only had to remember 2 rules. And 2 rules are very, very similar to each other. So don't get confused, but they're very similar. So what is derivative of natural log of x? Well, is equal to 1 over x. I don't know if I can show you that. I don't know. Hold on a second. Let me think about it. Y equal to natural log of x. I don't know if I can possibly pull it off. I never done this before. I can e to the both sides. Don't copy this down. I just want to see if it's possible to actually prove to you is 1 over x. E and natural log cancel out. The problem is it can be done, but you have to know how to do derivative e to the x. But we don't know how to do derivative e to the x. So that's not possible. So that's no, don't worry about it. It doesn't work. It doesn't work as a current skill because everything is scaffolding. Anyway, d to the dx here of natural log of u is going to be u prime over u or du over u. Either way, you had to, if anything other than x has to be u, right? And then any other way that you had to do. U prime over u. Now, so let's take d to the dx of natural log of x. We already know it's 1 over x, right? Done? Let's show you how to take a derivative of natural log of 2x. Now remember, you can set u equal to 2x. What is the derivative of natural log of 2x? What is it? Yes? Now here's a question, right? Why are they the same? I don't know if that answered the questions. But what derivative of natural log of x? Okay, let me show you how he did it. He said u equal to 2x, then du equal to 2. Does that make sense? So it'd be 2 over 2x, and that's equal to 1 over x. So why are they the same? Why are they the same? If you say magic one more time, no, just kidding.
It's the reasoning, just not. It's technically valid.
Technically. Why are they the same? Sometimes it's always interesting about how things work. That makes a better student.
If the coefficient doesn't affect whether it's like gonna change, it's whether like what the answer is, because like it's talking about like this.
Yes.
Is the coefficient a constant?
Something to do with that. But it's not something to do with coefficient. Something to do with constant. Yes. What? It might have a deeper understanding for that, yeah, but not what I'm looking for, at least right now. Yes, Ethan?
I was gonna say just because like E is a constant, so doesn't it?
What is it?
Like E is a constant. So
No. It's actually pretty cool. Right? Natural log of 2x. Can I do algebra first before I take a derivative? Now, can I take a derivative of this now? What's derivative of natural log of 2? That's going to give you 0 plus 1 over x. And that's equal to 1 over x. And that's why you see it on the graph, right? Derivative. So we're going to say f of x equal to natural log of x, right? Natural log of x. And the f prime of x. F prime of x. F prime of x is that blue line. But if I change this to 2, does that it affect the red line but not affecting the blue line? It affects the red line has a vertical translation. Does that make sense? If I change it to 3, what happened? Get it taller, the blue line never change. Because the constant doesn't affect it. Yeah, something to do with some constant. So good job, Laura. It's like thinking about things like that. It has something to do with constant. I think you guys are thinking about same path, but it just really is like just a basic understanding. So how do I take a derivative of natural log square root of 1 minus x squared? Now, I will tell you, do algebra first. This class is not calculus, it's algebra on steroid. And that's the way probably I define them best. As it's actually not my definition, most of the students' definition. Mr. Yeah, this is not calculus. This is algebra 2 on steroid. Can I change that to 1/2 in the front? Can I move to the 1/2 in the front outside? D to the dx of natural log of 1 minus x squared. Can I do that? Can I say u equal to 1 minus x squared? Can I say du equal to negative 2x? So it'd be 1/2 times. Now the natural log going to go away. So that's going to be negative 2x over 1 minus x squared. 2 is going to cancel out. Negative x over 1 minus x squared. Does that make sense? Now remember, today your homework, you're going to do algebra first. Because if you break down to each individual natural log, like expand it, like what you did on yesterday's homework, you expand it, then you can take a derivative individually. Yes. You saw it? Okay. Bye。
喂，等一下
好，你可不可以接我在10:06？
啊，等一下，
没有，我就来把东西搬一搬。
也 OK，好的。
The board. Yeah, board.
What board? Oh.
That's mine. Sorry.
We were gonna. What's up, Liam?
No.
Why you always want to have a staring contest with people? You're not gonna win with my fake eye. Hi. How are you? Where were you yesterday?
So on Monday I got extra shot, and therefore I was feeling nothing.
Mr. Gary, can I be honest with you for a minute? When I saw the homework you started last night, I was so pissed off because I was like, oh my god, this is so much. Like, why did we do this? Like,
But a lot of them are very easy, right?
no, it helped me a lot. It helped me understand a lot. No, but it was good though. Especially since you had to answer, so if I didn't know how to do it, I could like reverse engineer the problem.
Well, that's good. I'm glad it happened.
Sorry, I got
I don't really get the telescoping ones.
Telescoping, you just write out like first 5 terms. Huh?
When it asks like find the sum, like how many
It's on the
do you
board.
write out?
No, I was gonna say something along the lines of All this term. Yeah, well, once you notice the pattern, once you see the pattern starts to cancel out. And then whatever John can cancel out, those are the only things you have to do.
I didn't think he was paying attention.
Yeah, so it doesn't have only one left. Usually it's
Now he knows.
Oh, you like this. But if you have something like this, then you have to mark the fraction first.
There's nothing.
So something like this, and we give you other examples,
There's
don't
nothing
have to
happening
be like actually practice. One, we didn't really stuff like you. Really? Yeah.
Like, he just knows a bunch of crap about it.
Yeah, like,
You're not gonna have one?
What?
it's not like,
Oh,
I didn't know it's not until.
I haven't seen you drink it.
it's not like, it's not for like,
Are you there? Thank you.
We were getting like one third project. We were probably
All right, so shh. I want you guys to talk over how to do homework and teach each other. And like I said, I'm learning along with you. A lot of things I'm gonna be just as bad as you in many ways, but I'm gonna make sure I'm doing a good job. So, and the worksheet gonna help you because it has answer, just like Connor says. You can look it back. How do you do something properly? So talk to each other, and because you guys gonna be the best helper with each other, and with at the end, then we can say, okay, there's some question that we still don't know how to do, and we can figure out what is it. But yeah, so it was a lot of homework, but I meant to give you some more time to finish in class also. If you have more time to finish, that's fine. Today's homework is going to be on integral tests because we already teach you how to do integral tests yesterday. I didn't teach you yet. You taking the notes from who? Oh, okay. So does it make sense? Okay. So it has to be continuous from 1 to infinity. It has to be positive. And it has to be decreasing.
I figured that out after the fact.
Yeah, to be, if you have integral test, they will give you the integral of it. So they will tell you is it converge or diverge. But make sure you go do divergence tests first before you start out anything. Okay. I haven't given you an integral test worksheet yet.
like the fact that it's confirming you can't. They're actually making.
Jonathan, put your phone away and or unless you do it for the Emoto. Today's homework is gonna be integral tests. So we didn't give you an integral test yet. So today it's gonna be on integral tests. Okay?
I probably 27. I couldn't really tell. Because I like, I think the first star I got like 8/7, and the second one I got
Haven't anybody seen Mandy yet?
I'm not.
I haven't seen Mandy for 2 days, right? Anybody? Julia, do you know what happened to Mandy?
Wait, I'm not, I'm looking at 9.1.
Oh, it's still gonna be on.
Yeah, what's up? Yeah, because 3 equals
You know everything?
Yeah. It's gonna be going up way higher. Than the top, so it just goes to 0. You guys look. 3, even if it's different time, 3 to the second is 9, and 2 to the second is 4.
Yeah.
So the difference is just.
Oh, yeah.
It's 0. I got you.
Like, you don't, it's raised, you don't cancel the power. Yeah. That's why I use it.
So our value is yeah.
That's why. Oh, that's fine.
Oh, easy, I got it.
Yeah, where did you go? Where'd you go?
Oh, wait.
It's putting it for 20.
Literally?
Oh, there.
What?
Literally, you don't do any work inside. You just plug in all that stuff. Second page,
Yeah, I didn't teach that.
Wait, no,
It's like really.
I didn't teach that, so that's why. You don't have to worry about that part. They won't ask you that part. They will ask you what 1 plus 2 and 4. In case then goes, they will ask you. They won't ask you.
how do we tell
That is the correct. You have -1. Yeah.
And then 10 is
1 plus
11
2. It works.
I feel like it's overly complicated. For
It is probably overly complicated. I got it.
Oh.
It is probably overly complicated.
Just get rid of the 1 plus 2. Because you don't need it. It's just 2n minus 1.
You're not getting it the same way as before. You're yeah.
Third.
Oh.
Okay. 3. 2 times 3. Is it like the x minus 1 top? No.
Oh, you're doing the first one.
No. You plug it in by just multiplying the -1 thing by 2n minus 1. And it works perfectly.
So for finding the nth partial sum, what
You don't have to find that. Just find that 3/2 is fine.
because
have-
I saw the pattern and therefore I saw that the first term you will add +1 and the second term as it is. So here, and that's why I got the answer. For the second one also, when you do the partial fraction, you add +1 here, and then
Yeah, that's what you're
second one
supposed to. That's what you're supposed to. But it's okay. We're not. I didn't teach that part, so I don't have to worry about it.
Okay.
And that's that. The exam is not gonna ask you that ever.
Oh,
So it's it's not something that you worry about.
okay, and for yeah, for so 1 raised to 8 infinity will be indeterminate, right? So 2 raised to infinity will also be undefined.
You know,
We know that 1 is to infinity is undetermined. So 2 is to infinity is also undetermined.
Yeah,
For this reason, I wrote this undefined.
For like this part here was kind of hard, but after that, tough is probably 7 to 13.
I'm trying to think about what's the best way to approach this. I have something here. I just
This is not
wait.
where is
It?
So if it's anything but 1, if it's anything but 0, it's equal 1.
But what's the answer though?
Yeah, it's diverge.
I think about what's the reason why it's diverged though. If limit x n approach infinity is
Oh my gosh, you right. Do you want to do 26 minutes?
n approach infinity, infinity over infinity. And you do probably I would do L'Hopital rule.
It would be so complicated.
No, it's not complicated.
Oh no, he's right. Look.
Yeah, because it's infinity over infinity, right? And what is the
What's 2 is to infinity? Is it infinity?
Yeah, but they both are infinity though. 2 to the infinity is infinity, but so is n to the infinity though. Do you see what I'm saying? Like you have to see which one is gonna go faster.
For the expression.
Because if the bottom one goes faster,
Yeah, Mr. Ye, we have a question about one of these.
okay, give me a second. If the bottom one goes faster, then it's gonna go to 0. But it's the top one that's gonna go faster, or the bottom one's gonna go faster.
Why?
Because 2 to the infinity is still infinity, right?
Yes.
And n to the infinity is still infinity. But the problem is the only way to tell is gonna have to go through L'Hopital rule because we don't really know which one's faster. If you graph it, right? If you graph n to the 3 and you graph 2 to the n, you really don't know like what's gonna happen.
What is ln infinity?
It's still infinity, but it's much slower. I actually print out something. Yes, Greg. Give me a second. I printed out something yesterday.
Okay.
Maybe I put it back. So go ahead and check L'Hopital rule first. You'll find out that the top part is actually going faster, and that's why it's divergent. And that's how I would do. But derivative of 2 to the
N will be 2n ln to n, right? Upon 3n squared. Yeah.
So okay, hold on a second. Let me do that here. So remember that's y to the 2x. So ln of y equal to x ln of 2 as y prime over y equal to ln of 2, right? So y prime equal to ln of 2 times 2n, right? So if I take the first derivative, it's going to be ln of 2 n of 2 to the n over 3n squared. If it goes to infinity, it's still same thing, right? So that's ln of 2 times ln of 2 times 2 to the n over 6n.
I cannot see.
I just take a second derivative. I do L-Hopital rule again. So if because it's still gonna be infinity over infinity,
Okay.
and then they're gonna have ln of 2 to the 3 times 2 to the n over 6. Now, if we go to infinity, this part is diverge.
Oh,
Do you see what I'm saying?
yeah.
Because you don't know which one's going faster. As of right now, because the n to the 3 is going very fast. But 2 to the n is way faster. But how do you establish that proof?
Okay.
So for me that I printed out something yesterday, but I don't know where it left from. There's a college professor. They actually list down which one is faster than the other one. Hold on, let's see if I can find it. Derek Chung. So
And cos infinity and sine infinity, tan infinity, all are infinity.
huh?
Cos, tan, sine, infinity are all infinity.
No, sine to infinity is oscillating between 1 and -1. So you are actually divergent because you don't know which one it goes to. But if it's sine of sine of n over n,
Yeah.
then that's gonna go towards
Quiz
0.
theorem.
Yeah, let's go to the 0.
And
So
cos is also oscillating.
yeah, it's oscillating. The only thing that they are oscillating.
And tan.
Can as well.
No, tan is not oscillating.
10 is gonna go to infinity and negative infinity. Let's see. So here, when n is larger, natural log of n is less than n to the p, less than a to the n, less than n factorial, n to the n power is the biggest one. So this, I'm gonna give everybody this. Yeah, at the end, I'm gonna give everybody this. So that just kind of remember what happened of each thing, because you really don't know. I mean, you can think about this and you can get answer right away. Or if you really want to establish proof, it has to go to a hospital rule.
Oh, okay.
Do you see what I'm saying?
Yeah. Do we have to establish the proof in the exam?
Well, on AP exam, no. On the multiple choice, not. Like, so for example, you're on multiple choice on the.
This will be in the multiple choice, right?
Yes, some of them, but okay. Yes.
Yeah.
Yes. Most of multiple choice FRQ. What I saw, I look at the last few years. FRQ usually on the Taylor series and the McLean series, so they don't really focus on this part. Now they will focus on ratio tests and other tests. Those are things that you have to show work, not the divergence test. No.
Okay. Thanks.
So for 28, how would you explain why it diverges?
I don't know what the question, but
It's -1 to the power of n plus 1. So
that's it. What I think about is you only just sum up each term, right? And it's gonna be fluctuating between -1 to 1. So you cannot be defined into the one moment. Yeah, because it's fluctuating because of -1 and so it depends on the you and positive and negative. So n is even number of so if something that's going like oscillation diverges to values is not really second. If something that's going like this, and they are defined because they are going to each other, they're not fluctuating. But minus paper one would be like three would be three minus. Yeah, so if the sine n over n, yeah, because the sine n is oscillating, but over n is still gonna be the control. See what I'm saying? So you see that term that is eventually all those terms.
No, that's what I'm saying.
So now you write one more.
On how he does it.
And then the other thing that now you don't need to try to talk. We don't need to get it. No. We need to get it. You don't think because I know now.
What are you gonna do with it?
So what if I'll write out, I'm the only one who will see that.
Yeah, you write one more.
I will.
Yeah, would be mad at me.
Would you be mad if Nicole stabbed me?
No.
Look at that.
I'm not even mad.
Sharpening.
Nicole, write me enough. Arizona, she can get away with anything.
Yeah.
Mr. Yang, we've been there to help.
Okay. We can try.
An apple's permission to kill.
Okay.
You don't need to find partial sum.
Well, no, we found 25, we found yeah, I wanted,
You don't need to.
okay, and then 27 and
I will
20,
not touch
27 and 20.
That what you picked?
I'm gonna do it.
Yeah.
It's 27 was A.
First two terms.
And 27 infinite series. And this whole K thing is trying to confuse you, right? It's just like you did this thing with the X, right?
This is already the series. This is the app. So I go to the because this is already the series. Okay, and then this is the partial sum for all the terms. So
Wait, what?
that's already the partial sum. So if you said the first two terms add together, all you gotta do is plug in two. Oh, the first three terms add together, all you gotta do is plug in three. Yeah.
Wait, I'm confused still a little bit. Is it, what is this represent?
This represents partial sum. That's the sum of the series.
So if I said I want the sum of each term, that's what it is.
Yes. So if I say I want to sum the first three terms, all you gotta do is plug in three.
Okay. And is it the same thing for 28 and infinite series? What is the sum? What is the series divergent?
It's because you reflected it. Because if you think about it, the first term is gonna be -1, -1, -1, there's no certain value, it's certain values.
A1
You don't then both converge.
The first page.
that is -8.
That page, all I didn't get was number 2.
So that divergence test.
is plugged in, but the formula only
The
works
divergence test
R
and
-1.
what do you mean both? So the divergence because you wait, is that on the first page? You cannot tell you it's Converge.
Yeah.
Something for sure Diverge.
Yeah,
It's gonna say
So that's
now if it's equal to zero, and the next value is always starts with zero. So if it's equal to zero, so you start at So in this case, when they say if this is converged, then it's all two and okay. If this one is diverged, then and so in this case you have to make sure you have to get a top. You have to go through this. You take that and then
What do you mean?
yeah. So then you say okay, then okay, so you say that's two.
Two.
Now, if the part is diverged,
One.
Okay, if it's the wrong way, then why is it possible?
One.
you'll get a part.
Exactly. So I'm gonna do, cause that's what you're doing, you get to the next term. That's the third.
You have the next part is where you use the exponent. I know.
And that's 0.1. That's 0.15 times, that's 0.1. And then all over divided, because it's two. If you multiply what's the sum of the first term, and then for minus one ratio.
You can probably say,
That is pretty easy. Not a finite.
like if you start everything that's three,
If the first term is time, 1 minus r to the nth term over 1 minus.
but whenever it's expanded, it's not.
Yes, there is.
It's still gonna be like something like this.
So it's
It doesn't matter which one has.
Oh.
They just keep on going. Keep on
Point
going.
one. Times 2. Zero, zero, zero.
Oh, the parent secret.
What's that? 1 minus.
Yeah.
So you should be talking about, yeah. Whoa.
We're not far. When you and then we know it's positive one. So
And then you. Yeah, which is that's right.
that one is I always
And then this would go to 0.
about 3 times.
Probably.
Oh, yeah.
Yeah, it's just gonna give you
Oh,
the bottom and the top scale. So sometimes like the probably is not something to give a question. They say,
When you go until.
but do you really want to do it?
That makes sense.
2 divided by 9.
Not even the album, but we can actually do some more.
We did it once, right?
I did it in front.
Oh, we could just take it 2 out.
My convention, so it's 100 times. 100 times I'm gonna be okay.
Okay, so then you can just assume that the
Okay, so now I get number 7.
right, okay, and then say.
Yeah, sure, just leave it.
Oh, number 6 is the same thing, I just.
Oh, yeah,
Well,
for
I just
80,
saw
the first
it.
term, it's one third.
Yeah, that's about what I think about 105. Because 105 so 1 to the x value is so sometimes it comes first.
You just have this. It's a finite series. One over 3 to the 4. Why are there such high power?
I don't want it. Like,
But you shouldn't have any power to the bottom. 1 minus the ratio. Not in the format of finding it.
Nicole, you doing okay?
Yeah, okay.
Neither is. You know, that one is evaluated.
My dad texted me off.
13 is going to find.
Are you guys okay?
No, we need help. We haven't even tried the question. Sorry, not this one. We haven't even tried the question. It's not the right. Okay, so I know that this is the formula for a finite series. But that's not in the same format as that for it wants to evaluate that. It wants to evaluate the theory and it's finite. I don't know how you come to one of these.
1 over 3 times 1 over 3 times 1 over 3. So when you do 1 over this, so you have 1 over 3 times 1 over 3. And
you probably have to
3
read
to
it.
the third is 27. So 1 over 27 times 1.
If I were to use that equation, I would write it.
Yeah, I was always
Where did it equal?
How would you do it if it's unequal to 4?
Yeah.
When you do
Eleven,
it,
one,
it's
six.
four. When you choose to plug it in a 4, the A1 would be. No, it's still 7. Yeah.
Did anyone get number 11 on the second page?
I think so.
I got an expression, but it wasn't what it was.
Exactly. I want to know how to get it to how they.
Yeah. I got like 1 over 3 to the 17th power instead, not 3 to the 17th power.
Yeah,
And then numerator.
your QR simplification.
Yeah, that's good.
You have a lot of.
That's simplification.
Oh, no, I'm good.
Yeah, it's algebra.
Yeah. Algebra very good.
Yeah, I will. They will ask you anything about so much. They will ask you. I think 13, 14, you can do anything you want to do E and the entire class.
One of them is easy.
No, it's
Like,
they're plugging in one person here.
Are you working with? Not that, not me. It's like
Yeah.
So we got the one. Actually, no, I didn't. For this one, like. We were building formulas and like. Is the one that's
The ratio?
it's smart.
0 and then
Everyone knows.
Martin got us to do that.
E to the third. Oh, no, the first one's E over 3. The second term's E over 3. Yes.
For what?
Wait.
Oh.
We write it about.
He yells at everyone for
No, it's the math.
I was happy I got away from him.
Oh, we're gonna get it back.
Yes, we're gonna get it back.
Oh, no.
Oh my god.
That's what I'm worried about. We can't make it to the time.
I know, but I don't remember the draft in my head.
When you need to this back, it can't make it.
Wait, E to the 0. No, it's E over. The first term is not E over 3.
Yeah, that's the same thing.
E over E squared over 3.
Yeah, E over 3.
So why they use that in math?
You said E over 3 right here?
You don't have them.
Okay, and then
E over 3 ratio.
so the first term is just E, so it's E divided by 1 minus E over 3.
So I just wrote that.
Now we have to simplify that.
Why do you have 0.75?
They want the point.
That is right.
That is, yeah, sure that.
Not plugging the infinity there, that would be.
When we multiply 3 to the top and bottom, we get
I'm gonna cry.
3e over. We get that. 3e over. It's b. 3e. 3 minus e. Oh, I see why. You multiply top and bottom by 3. That's exactly what it is.
$10 the first 3 days we have.
No.
No, he still told me already, it's been 2 years. He went up to my TV because
Yeah, I'll put $20 at the first thing and then you add new up and everything.
that's a lot of yeah. I act like a lot.
I see what he did, but that's so much extra work.
I know.
I literally didn't actually write it down.
That means
I'm so glad that you know what, but I can just make it. Did it, were you weren't in my class, were you?
No.
We pulled out the rest from my daughter and he made the entire.
Yeah, hold on, I think that's all the questions I have. It is that. Yeah, dude, I
Just like
knew
right
that
before
was
the-
11, so I'm gonna have to figure that out.
He's like, look, her. And then there's
Yeah, well.
her friend, he's like, happy to be one, the one at the piercing.
Oh, God.
Okay, so I want to talk about one more thing today. Super easy concept. It's a P series.
Oh, no.
P series is the one of the easiest series to understand,
Oh, we've already seen a question like this, right?
probably. But P series has P series is very easy. It's 1 over n to the p. If you see any time that you have this situation, 1 over n to the p, which is it could be just plug in numbers, so it'll be 2 to the p, 3 to the p, 1 to the 4 to the p, will always converge if p is greater than 1. Because what happened when p equal to 1? Do you guys remember what series is that? That's a harmonic, right? So if p equal to 1, it doesn't work. Less than 1 doesn't work, but has to be greater than 1. If it's greater than 1 and is positive, continuous, and decreasing on the interval, so PCD here, well, CPD or PCD doesn't matter. So if this is the case, it's going positive, continuous, and decreasing, and then it's 1 over x to the p, will always diverge if p is less or equal to 1. Less or equal to. So I understand the condition here because equal to 1 is harmonic, but if it's less than 1, it's even worse. It's going to be divergent very fast, faster than 1. If it's above 1, let's say 1.1, automatically converge. Okay, even 1.01. Longest is greater than 1. Because the equal to 1 is harmonic. But a little bit greater than 1, it's automatic converge.
It always has to be positive, continuous, and then decreasing.
Because later we're going to talk about alternative harmonic motion, harmonic that can actually converge. Because if you have 1/2 minus 1/3 plus 1/4, that could be a different issue. That's why you always positive. So therefore, in this is a super thing. So today's homework, you're gonna have 2 things. You're gonna have P series. You're gonna have integral tests. Okay, and you're gonna have to find out what this thing is. So we're gonna give so for example, if 1 over n squared, since this p is greater than 1, this is always converge. That's all you have to write down. P series, p is greater than 1, converge. Done. Move on. Super easy. Okay, and you're gonna use this a lot later. It's called comparison test. So you compare 1 over n squared and 1 over n squared plus 1. You compare both things, and you can use something called limit comparison test. So limit comparison test is going to be also give you more tools. Right now, we're going to give you as much tools as possible. So right now, our tools is going to be divergence test, right? And we got what? Integral test. We got geometric series. We got telescope series from yesterday. And then we got the integral test now in P series.
For P series, why would it be less than or equal to 1? Why would it just be less than 1? Because
when it's equal to 1, it's harmonic.
Oh, okay, that's one. Okay.
And harmonic is proving to be always diverge.
All right.
Okay, so, hold on a second. There is a way to prove, the harmonic is things, but I'm not going to go over right now, but there's a way to prove it. So, is this converge or diverge? Well, I already said it here, right here, but it's divergent here because this is a 1/3 power, right? This is a 1/3 power. If it's a 1/3 power, is what? Less than 1, so it's divergent. Could be 2/3, could be anything. So make sure you understand you can convert the radical into the exponential. And if you convert that, you can actually decide that really, really quickly. We're gonna do one that we're gonna deal with this one.
Bottom to 1 over n, e to 1 over n.
We're gonna do summation n equal to 1.
Wait,
To-
so for P, does it have to be 1 as the numerator?
Yeah.
Yes, okay.
So do you guys write down questions?
Are we gonna do the integral test on this?
I don't know. You gotta figure out. So first, make sure you go do divergent test first. If it's a divergent, then you can stop, right? What time we got? 10:06, right? You can do P series because the numerator is the e to the 1 over n. But you had to prove a couple things. You had to prove PCD here in order to do integral test. So the work is a little bit more. Also, I want to show you something here. I think one of the students was asking one of the question. I forgot what the question was. 2 to the n over nq, right? That question I did L-Hubble rule, and I did it on the board. And some people is thinking about which one is gonna be faster. So usually this gonna be this gonna be right here, n to the n is going to be fastest compared to everything else. And then n factorial and a to the n and n to the p and natural log of n. Natural log of n is slowest. So you sometimes you compare the rate, right? Numerator and denominator. If a numerator has a faster rate, then it's divergent. So that's something that I will tell you. Now this is something that intuitively, if you don't have time, because on AP exam you don't have multiple choice, you don't have to show work. Then sometimes if you understand those short tricks, that you say, okay, well, you think about it, natural log of n is gonna be, they grow much slower rate, right? Because everything has natural log something. So that's something that you do. Make sure. That's what something I have to show you. Now this is by a professor. I didn't come up with this, but so it's pretty good. So right now we are right here. We're right here in this moment. We have finished all those things. We didn't do squeeze theorem because I didn't think that we will use it. But we have done geometric, p-series, divergent test, integral test. Well, we have done those 4 here. The only thing is that later on we're going to talk about comparison test and limit comparison test. So you really need to have a p-series done, and you need to have an integral test done. I will give you this sheet for you guys. I will send it on the Emodo. Okay. So later on you can always go back and look at the sheet of which test I should use and which test is most efficient. So did you guys finish that one? The answer is not E. After integral test, the answer should have been something else.
Oh, he's going to take an integral to find it?
No, but you... Okay, so right now, today's worksheet, you're going to have 2 things. P-series, integral test. Okay, P-series super easy. I think we can teach elementary school kid to do P-series. But the integral test is the one that you're going to have a little bit hard time because you have to take improper integral.
Oh. No, I say no. No, improper integrals aren't even that bad.
No, it's not that bad. But you do but you do need to understand e to the x graph. You don't understand e to the x graph? Are you serious?
Slightly understand the answer. It's like any possible number of 2dx. Yeah.
Look, memorize two graphs for improper integral. One is this graph, e to the x, right?
Yes.
If it go to negative infinity, it's going to the 0. If you go to infinity, it's positive.
Yeah.
Understand the second graph, our tangent graph.
Okay. Yeah.
What is pi over 2?
2 negative pi over 2.
And negative pi over 2. So if the arc10, when you have arc10, if you go to positive infinity, it's going to be pi over 2. Negative infinity is going to be negative pi over 2. Okay, so knowing those 2 graphs helps.
Yeah.
Sometimes you might have to deal with natural log of x graph.
Oh,
Right? Natural log of x, go to here, it's going to be, go to 0 on the positive side, it's going to be negative infinity. If you go to positive infinity, it's going to be infinity. But it's very, very slow way to get infinity. Like super slow. Huh? I think it's you're very close. It's e minus 1. You got e minus 1.
Where are we taking the integral up?
You take you because due to this situation that you're gonna do integration between 1 to infinity of the functions. So you gotta change that to a function first, and then you do integration between 1 to infinity of e to the 1 over x squared. Yes. Yes.
How do we know when we're supposed to do the integral test as opposed to just trying to find like a ratio or?
Okay, so p-series doesn't work. Telescope doesn't work. Geometric doesn't work. So if else doesn't work, integral test. As of right now, because later on we have more tools, but we learn in this order. We learn divergence test. That's like a in chemistry. That's like kind of like the first thing you do to check. Is it solid or liquid? Pretty much, right? So if it's solid, you don't need to do tests. Pretty much that's like this. Is it liquid, then you can do other tests. The solid, you can just kind of observe and touch and feel. I don't know. But the divergence test is very, very important because if it's divergent, if it's solid, I don't have to do anything.
Wait, what does E minus 1 mean? It means it's divergent because it's not zero.
That's actually convergent. It's convergent to a value because if you do integrate of all those value, then that's going to be sum of those value to be equal to E minus 1. So therefore, it's convergent.
Oh, but if you did the divergent test and you got to E minus 1.
No, if you got divergent test, if you got any other value than 0, it's automatically divergent.
Oh, I forgot the next.
And I got a 3 today. I beat you guys. So you wasn't lucky with absolute skill. I'm back.
What?
You have minions on your test.
That's scary.
Where? Oh, that's my new thumbnail. You want to see it?
I would love to.
That was a cute one, actually.
Oh my god, I love you.
That's my eyes.
I went stupid.
But that's kind of mean. So I'm debating whether I put up.
So funny.
That's amazing. I'm so happy I saw that.
That's pretty.
It's jump work.
When do we have the next test?
We probably have something this Friday. Yeah. So, but I want to make sure you good at it first because this is something that I myself it's gonna have a little bit hard time too because I don't have experience on this part. But it's okay. We learn as it goes. But right now, I think we are doing a good job. So it's not like we're not doing traffic yet.
And who is getting 125 points in that competition?
Who's getting what?
125 points. Do you know you send the chart of the rankers, first, second, third.
Oh, first team we got 125. Second team we got 62.
So is it the individual test?
No, individual tasks. Individual tasks I didn't send. I did not send individual tasks. But you can see an individual task if you go to the website.
Which website?
For the amount.org and just look at the result and you can see you didn't do good. That's okay because you're not.
I didn't practice actually when I saw the test and I thought, oh, I should practice this formula because I completely forgot some of the methods.
But the thing is, it's
a lot of the past and I should practice a lot.
yeah.
before-
No, that's okay. And so, like I said, the people who got, I have a student who got -2 before, and she went to Vanderbilt for a run. She said,
What I got?
Huh?
What
You got 7. You got 7. But that's okay. That's like I said, I don't expect. And Marco got 9, so it's like and Eva got 20.
Okay, I didn't want to hear it.
Yeah, but that's okay. No, like I said, it's not a test to judge who you are,
Yeah.
but it's
It will be better if I revise and studied for it because then I regret in the test that I remember this but now I can't.
But now you can go back and still remember because they might see it later on AP exam.
Yeah.
But not all the questions there are going to be on AP exam. It's like maybe like
But it's good review.
yeah, in some way. In some ways, it's like the one that inverse derivative. That's a good review.
Yeah.
So,
I'm free.
bye.
你们来接我吧，这喂。Hello?
Students, 1 minute remaining until class. 1 minute remaining until class. we look at thematic research powered by data science and alternative data. Look, our approach towards looking at major macro issues is anything but normal. So, for example, when we talk about the course, what we've done, we use geospatial analytics to monitor 22 of the world's largest and most influential ports. What we do to try to understand what's happening at each port is we effectively use a geofence where we draw a boundary around the port, offshore port. And then with that boundary, what we effectively do is we leverage or monitor ship transponders, so AIS. And what we do is we look to see when they enter our boundary, when they are ultimately discharging at the port, and when do they leave the boundary. And effectively, what we've been able to do is monitor the pace at which ships are moving, navigating in and out of our boundary. We call this the time of turnaround. And I think what's really important is with the port of LA and Long Beach, which is, of course, the major port that we're all so focused on, what we're seeing is that it's taking roughly 7 days to turn that ship around. And versus pre-COVID, that's about 3.5 days. So it's taking twice as long for each ship to really circle through the port. And the last thing I like here, Dom, is we're able to leverage foot traffic and understand geolocation to understand how many people are actually at the port. What we've seen is that the port of LA and Long Beach, we've actually seen a pretty significant rebound in foot traffic, which really gives us confidence that this is not necessarily a worker shortage issue. This is a real consumer demand issue in terms of the port backlog.
So if it is, I mean, the Biden administration has made a lot of comments about how they're trying to solve these issues, that traffic is getting back to normal. What do you see trend-wise? Is it moving in the right direction? And if so, how long does it take for us to get through all of these issues?
So it's such a great question. Look, I would be cautious in calling for a real trend or timeline right now. And the reason why, Dom, is back in the fall when supply chains were all the craze, we all really thought that things would linearly improve. And I mean, why wouldn't we, right? To your point, number one, we saw Biden call for the ports to open 24/7. Number two, we also all thought that as COVID starts to taper, more longshore workers would come back to work. More workers means more efficiency, you move more freight. And number three, post the Christmas surge in buying, we all thought, of course, if you're buying less stuff, there's just less ships to show up at the port. Now, if you have that trifecta, naturally a logical person would think things would improve or loosen up. Now, what we're seeing is that some of those things are really rare red herrings, and the reason why is the port is just so overwhelmed due to the massive inflow of demand for consumer goods.
Sure.
Now, I want to be clear, this is agnostic of COVID. I mean, our math is showing that these ports were just never built to handle this level of ships or this demand for goods. So hypothetically, if consumption were to remain elevated at current levels, i.e. demand for goods continues this strong, yeah, hypothetically.
Interesting point there, Michael. It makes a case there that maybe infrastructure is a big part of any kind of solution. RPC, thank you very much. We appreciate it.
Thanks for having me.
Still on deck for the show, the morning's first set of movers,
Who
including
the hell is that
triple
kid?
dip. Investors showing no love for semis.
What an idiot.
Dashing dreams of a 2022 Cybertruck and $25,000 electric vehicle, but he's very excited about one thing. Find out what it is when Worldwide Exchange returns after this.
Join the CNBC Investing Club with Jim Cramer. Be a member first. Get tips straight from Cramer. The only club with exclusive
Right.
trading leads.
Well, I can see that. I mean, like, what
I'd really just eat it rice because I have nothing else to eat.
Investing Club.
oh, well, what?
Spicy. I put some spicy sauce.
Oh.
Welcome back. Time now for your big money movers. 4 stock stories of the morning and what we're calling a chip triple threat. First up, Samsung. Lower in Asian trading, the chip maker reporting profits rose 53% in the fourth quarter. Its best result in 4 years. That was in line with the company's forecast, but lower than analysts expected due to the conservative shipments of memory chips. Now, Samsung expects a recovery in demand for tech devices this year, but warns of ongoing supply chain and COVID-related issues. Those shares down about 2.75% in Korean trading. Number 2 is Intel, also lower in the pre-market despite posting record fourth quarter revenues. But the company's first quarter profit guidance did fall short of estimates. While Intel is confident about demand and its ability to manage supply chain issues, CEO Pat Gelsinger expects those constraints to linger into next year. Intel shares off 2.75% in the pre-market trade. And by the way, Gelsinger will be on
Sean, you all right?
later on today at 11
You don't
a.m.
look-
Eastern Time, a must-watch interview there. And on the other hand, shares of Seagate are jumping after the disk drive
You
maker
put a lot more
outlook
into psych than
wider
calc, right?
margins ahead. Seagate also reporting its highest revenue quarter
What?
in more than 6 years on strong demand from cloud data.
No, in
center
general, you
customers,
put more
with
effort
shares
into
up
psychology.
7% in the pre-market trade. And finally, check out what's happening with Teradyne shares right now, down 50%.
You could have get good grade here too.
First quarter guidance fell well short of projections. That offset better than expected fourth quarter results on stronger demand across test and industrial automation markets. Teradyne designs and manufactures testing equipment for high-profile clients, including Samsung, Qualcomm, Intel, Analog Devices, and Texas Instruments and IBM, amongst others. Well, let's get a check on this morning's other top headlines as well. NBC's Francis Rivera is in New York. Good morning, Francis.
Hi, Dom. Good morning. President Biden is wading into a new political battle over the future of the U.S. Supreme Court. A source confirming to NBC News that Justice Stephen Breyer is scheduled to appear at the White House today with the president. The 83-year-old justice is expected to formally announce his retirement from the bench. As for who could take his seat, Ketanji Brown Jackson has emerged as a frontrunner. She is a Harvard Law graduate who clerked for Justice Breyer. She was confirmed last year for the U.S. Court of Appeals for the D.C. Circuit. Also in the mix is Judge Leandra Kruger, who has served on California Supreme Court since 2015. She has argued several cases before the U.S. Supreme Court. And if confirmed, the 45-year-old would be the youngest justice on the bench by about 5 years. Now to the growing crisis in Ukraine. Secretary of State Antony Blinken says the U.S. offered Russia a, quote, serious diplomatic path forward, but rejected Russia's demand to ban Ukraine from joining NATO. This as Russia ramps up its military drills on the border of Ukraine. A Western intelligence official tells NBC News Russia has 112 to 120,000 troops along the border in a 60-battalion And the record-setting Jeopardy run of Amy Schneider met its match last night. Schneider's streak of 40 straight victories came to an end after losing out on Final Jeopardy. She finishes her historic run with nearly $1.4 million in winnings. Chicago's Roan Talsmo was crowned the new champion. As for Schneider, she'll be back for Jeopardy's Tournament of Champions this fall. And even more valuable than that, for some, she's representing when it comes to the LGBTQ plus community. So I'm sure she's proud of that.
Very high profile for sure. To Francis Rivera, thank you very much for those headlines. Straight ahead on the show, it was Rogan or Young, and Spotify has made its choice. The latest developments in the Neil Young versus streaming giant saga that's coming up straight ahead. We'll be right back. Futures and global markets under pressure as the Fed gets set to tighten the reins for the first time since 2018. Investors unimpressed with Tesla and its record fourth quarter results as Elon Musk lays out the challenges for the company in the year ahead. Chips are a big part of that. Plus, Apple gets set to report its latest quarterly results later on today. What one industry analyst says is the #1 headwind facing the stock ahead of that big tape. It's Thursday, January 27, 2022. You are watching Worldwide Exchange right here on CNBC. Welcome back to the show. I am Dominic Chu in for Brian Sullivan today, and here's how stock futures are looking halfway through the 5 a.m. Eastern Time hour. I'm going to call them stable, but this doesn't tell you the whole story. The S&P is implied higher by 2 points. The Dow Jones lower by just 15, and the NASDAQ higher by 29. It looks okay, but check out the action over the past few hours. We are well off our session lows at this point here. You can see at one point the Dow Jones futures, 400-some points at one point I checked later on this morning, and it's been a steady rise over the course of the last, call it 2 or 3 hours, to just about flat for the Dow Jones futures. The NASDAQ, by the way, NASDAQ futures are down about 2% and have now rallied back to positive territory, so the volatility continues. Watching yields now as the Fed signals its first interest rate hike since 2018. It may likely come in March, right near 2-year note yields a hair above 1.18%. So we've seen a move higher pretty sharply in the 2-year side of things. Meanwhile, the 10-year note yield ticking modestly lower to 1.84%.
All right.
Last trade there. By the way, the third.
Is Darby here? All right. This car's shrinking by the day.
Apparently so.
Wait, Fame just come back and he left again.
Yeah, there might be something going on, like a.
Going now.
I saw my friend Julio and I saw at the beginning of the day, and then I left there just gone. Like,
Oh yeah, Julio was there as well, yeah.
yeah, he just wasn't here, and then there's other people that are like, it's not here yet, and lunch like. I don't know what's happening. Maybe it's like college just.
That could be
I don't.
the choir juniors.
I'll be weird.
You give them hope? You shouldn't give them hope. Not yet.
Today has a college visit.
Today is Lunar New Year.
Yeah.
Oh, that would make sense when they book.
Yeah, oh, actually, yeah. Julio and Axel.
Right.
Oh, that makes sense. Trevor and Jackie's not here. But I'm here. I'm Chinese.
Right, like even so, my mom's like, was like, hey, you want to go to school?
You're an adult. You choose whether to do it.
Don't you get like those red envelopes for money?
Yeah.
That's not for Lunar New Year.
Oh, it is for Lunar New Year. I thought it was for Lunar.
That's why it's the best holiday in the world. You get cash.
Who do you give money to? Like, your grandparents give money to you?
I get cash on my birthday.
What?
I get cash like, whenever it's like my birthday, usually like my relatives, they just give like cash and like envelopes or something.
Yeah.
Every year.
Yeah, much more efficient than Christmas present.
Exactly.
Yeah, no.
You can get anything you want with the cash.
And you don't have to like, your relatives don't have to like assume what you like. They just give you cash.
Yeah.
What I kind of do now, we used to do presents, but like now I was like, I have to like give you like anything you want, like cash, preferably, because I can use it on next time in the day.
Exactly. I tell you, I think Christmas is stupid. Because Christmas is invented by Macy's.
But like give me
Never mind.
Yeah,
I fear you would.
Never mind. I feel it was.
I think so.
I would see like.
Yeah, Hero Pass already?
Huh? Yeah, I got a pass. Not a hero pass, just a regular pass. I already have 2 hero passes. So bad. If I get another one, I'm gonna get attention.
Oh. Yeah, skip by it, right?
No, I have. I think.
Don't worry, if you get suspended, I'll rescue you.
Oh, really?
Yeah. I always told the people that I feel bad for the people that handle suspension. It's gonna be room full of people's. Like matter in like 2 weeks.
I'm borderline suspension or detention or whatever.
Why?
I got a parent email today too.
Hey.
Yeah, I'm not doing very good.
For what?
For being tardy.
Which period?
First period.
Oh, I'm always like, I just walk through the train.
No.
Kira told me about that. You guys are so lucky.
And then the police came in and was like, why are you letting people in? Like, and I say, okay, it's not.
Oh, you just go out of the studio.
Yeah,
They're making people like.
I saw you pulling up. I thought it was like, here's Sean pulling up like eyeball.
you
So I said, if I'm gonna be late, I'm just gonna.
Right between there.
No, if you're worse, the worst is come here.
Go around the school.
No, go to, drop off over there.
You'll let me in?
I will let you in.
Aw.
I'll leave a window open. You can climb in. I'll be like, I don't know what happened.
Did I see anything?
Whoa, that's just a Jackie. I don't know what happened. Do you need a pass? I'll write you a pass.
Actually, wait, I might see that one.
Out here knocking. Who? Who?
First, you'd be so confused.
I already told Will. Will's already have 232.
Well, first, sir?
Yeah.
Yeah, I know.
He's already behind you on the
I
line.
see him in the morning. We are both late together.
There's a line.
I said, Will, just come around here. I'll leave the window open. He's in my first period.
Oh, okay. That's
So he can literally just climb in.
How many parties can you get it for suspension?
I don't think that's gonna stick.
I don't think so either.
Unless they have like 10 classroom of suspension.
There's like one kid in my like sixth period class who has like 100 years. She hasn't been here in like 100 days. Really? Yeah.
Well, it's really
I think I graduated.
it at least haven't been here for like almost 3 months.
It's like scrollable. All my parties. You just scroll through all of them.
I don't even bother to check her attendance anymore.
I can't get myself to come to school.
Oh, is it just first period?
Just for the period.
Okay.
Well, and
I thought you were like.
But can you just skip the whole first period and just come in a second period?
I can.
But do they still give you tardy press? If you just show
I
up
don't
at
think
second
so.
period?
I don't think so. That's my plan. If I'm late tomorrow, I'm just gonna skip it.
Yeah, what's your first period?
Newspaper.
Yeah.
I know, but it's an important class. 'Cause I can
Then
read.
you should be here early.
But it's not that important.
All right, homework questions.
I worked too hard on it.
I know, I heard you did like
Oh, yeah. Oh my god.
I did not. I assigned first 4 question all parts.
I did it, and then what happened was when I like, so I got one thing wrong.
All right, so
Maria did too, and she was like, I
did this in like an hour and 90 minutes.
I know. I was like, what the hell is going on? What's up?
Wait,
It was because I was ranting.
What was happening on WhatsApp?
her and Maria ended up doing like all of the homework. You only supposed to do like the first 4 parts.
Yeah.
Right? She did like did all what is it? All parts?
I thought he did
Yeah.
the first 6 in class, but then I believe
Maria was just freaking
Where I
out.
go back.
Plus it's all what is it?
He cried in the corner too.
Yeah. Yeah, sometimes man, it's just it's fun.
I've done it before.
I did it right.
I mean, you could have asked. You could have asked. Is it due first?
By then it was already too late.
Okay. Well, good thing you know about logarithm now. Hopefully. All right. So, which one you had a question about?
2, 4. The 4th problem.
2, 4. B log B just cancel out. That's a. They are called. They are inverse to each other. That's one of the property. I didn't give it to you now. Yeah, but that's the property. Other questions? Three 10.
You put the 1/4 outside.
Yeah.
and everything inside.
Uh-huh.
So would it be the same thing for 11 as well?
Pretty much. So I will do 10 just in case if you need it. So this means log of x3 y to the square over z to the 4th. This is to the 1/2 power, right? Okay. There you go. Does that make sense? And that's going to be 1/2 log of x3, right? Plus log of y squared minus log of z to the 4th. I'm going to take a 3 down, so it'll be 3/2 and distribute 1/2 at the same time. Two log of z. Does that make sense? Yes or no?
Where did the 2 for the y go?
The 2 is going to be in the front, but the 1/2 is going to distribute. So 2 and 1/2 cancel out, become 1. Questions?
I just have a question. That I want to ask. Like 2, 4. So log of b, log of b is 1.
Mm-hmm.
So what is like the rule there? Is it just
Because the exponential and logarithm are inverse to each other, so they technically cancel out. And we're going to talk about something very similar later.
I just want to make sure I'm doing this correct. For 4, 6, was it it's 6 to the -2?
4, 6? Yeah, 6 to the -2 equal to 1/36. That's it. You know who else late? Will Purser, Sergio.
Both of them together?
They're always in physics?
Yeah.
I think it's been the only times.
They always late.
The teacher himself makes fun of him. And he's just like awkwardly sitting there.
You know who I was late? Me. I come here at 7:20. I just park in the back. I have a whole line of students outside waiting for me. Go ahead. Yeah.
I started at like 8.
First period?
No, I just come here like 2 minutes before the period starts.
Hey, good news. Apparently college classes only start at 8 o'clock. Or at the earliest.
No, 7:20.
Please let me dream, Mr.
But you don't have to register for that class.
Yeah, that's fine. Wait, do they have multiple classes in a day?
Yeah. I have
College?
It's the same as our multiple classes. Yeah.
Oh, your class is gonna start at.
Well, one class starts at 7.
I take a one class at 7. I never went there. I just failed that class. Oh no, I did that. I almost failed. It was a geography.
Yes, come on, Mr.
Okay, that's true.
All we gotta do is like know like latitude and longitude.
Right? Like, where is India?
Oh god.
All right, next question. Any other questions?
Hold the number question 3.
Which one?
I want to see if I got.
Well, this is 11. 11, I did 11. It was 5/4 log of x minus half log of z. And the work is right there. That one's the hardest one. Because it was square root inside a square root. Three 11.
Oh yeah, where's the answer?
The work is right here. I break apart first. And I move the 1/2 power in the front. And I break up more. Right. And then I break up more. And I distribute, and I combine the 1 and the 1 over 4. Does that make sense? Is the Iridis coming back or no? She said she was. Next year.
It should work for 11.
And this is work for I don't know what that work for. I think last one maybe? No. It's not. I lied. I don't know what this is work for. Yeah, I don't know what I work for. Any other questions?
Three.
3.
You just take them both on the outside and just.
Yeah, so it'll be 1/2 log of x plus.
Hey, why would you get one? Oh yeah, okay, never mind.
Square root is 1/2 plus 2 over 3 log of y minus 4 log of z. Do you understand it?
Yeah, I was confused because when you said 1/2, I thought you meant on the outside. I was like confused, but I understand.
Well, square root is 1/2 power. Yeah. So you had to understand this rule. A o m over n equal to nth roots of a to the m. And that's it. Other questions? No, maybe, yes, maybe. Okay, so we're going to talk about what today is. So today we did talk about the reason why you got a exponential function, which just looks like this. Okay, and you have this function. Okay, and what's the relationship of those two functions? Okay, so there was a relationship, obviously. Do you guys know what kind of relationship between y equal to 2 to the x and log 2 to the x? What's the relationship to y equal to 2 to the x and y equal to log 2 of x? Ah, good, good, good. So let's finding the inverse, right? So if I find the inverse, I change the x and 2 to the y, right? How do I get y by itself? Y is an exponent. How do I get y by itself?
Teacher, please release your students for B log.
How do I get y by itself? Anyone? You do. You do. Ln of x of y equal to y. No, sorry, the other way around. So you do natural log actually. So so ln of x to the y is equal to y ln of x. Log of b of m equal to log natural log of m over natural log of 2. You do log natural log of x equal to natural log of 2 to the y. Does that make sense? And then remember, this is the only way you can bring the power down. This is a very, 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 very key tool to solve a lot of equation. So you can bring the 2 down, bring the y down, so it'll be y ln of 2. And now you can solve for y, so y equal to ln of x over ln 2. Now, due to the changing base formula, so I use this a lot. And due to the changing base formula, that's going to be log of 2 of x. So you just convert the inverse function of 2 to the x is going to be log 2 to the x. So this is the rule I apply here. And this is the rule I apply here. Any question on what I did? Okay, so now I understand the relationship with this and the other one.
So the fourth would be divergence. It's log b equals log m over natural log of 2.
Yeah, no, ln of m over ln of 2. But since in this case I have ln of x over ln of 2, then can I just change it to log 2 of x? So the idea is using this and to find out the inverse functions. So remember earlier we talked about what is this one, right? What is b log of b of x? That's just equal to x. The reason why is this is exponential to this. So do you guys remember 10 and 10 inverse? So if you have 10 of something, of a function, and if I front, I have 10 inverse, they pretty much just cancel out because they're inverse to the other things. And they here is b log b are inverse to each other. If they inverse each other, can I just cancel out? Does that make sense? Are we okay here? Okay, so now we're going to teach you solve two kind of equation. One is, what if I have ln of 2x minus 1 equal to 5? How would I solve this equation? There's two ways you can approach it, but how would I solve it? Huh? You cannot natural log of natural log.
Oh, wait.
Yeah, technically, but the way the E works is kind of like you need to use this property, right? You have to do the exponent. You have to push this thing to become exponents. So this is the first way I would do it. I'll show you second way, but you can do this E to the natural log. Remember, this is supposed to be log E, right? Does that make sense? And E log E, would I cancel out? Right? So I'm just going to E natural log of this to the power 2x minus 1 equal to E to the 5. Does that make sense so far? And that's what E and natural log, they're going to cancel out. And that with the 2x minus 1 equal to E to the 5. And then 2x equal to E to the 5 plus 1. And x equal to E to the 5 plus 1 over 2. Does that make sense or no? Let me know if it doesn't, because we cannot go further if it doesn't.
What is the relationship between E, natural log, and log? I'm still very confused.
Okay, E, remember yesterday we write down ln is represented as log base E, right? Do you remember that? Now remember this, if this one I can rewrite as a log base E, can I do E to the log base E? Just like the question you asked me, B to the log B, they will cancel out. So what I did is I E to the both sides, and I raise the power to both sides. So E to the log E of 2x minus 1, and that's equal to E to the 5, and E and log E cancel out, left with 2x minus 1 equal to E to the 5. And I go ahead and solve it. So if I solve it, it's going to be x equal to e to the 5 plus 1 over 2. Now I'm going to show you a second way. Second way, I cannot do it as log base of e of 2x minus 1 is equal to, were you here earlier? No, were you here earlier? Okay, I was not here, so that's fine. Give me a second. E to the 5, right? Equal to 2x minus 1. And you're going to get a same step. E to the 5 plus 1 equal to 2x. X equal to e to the 5 plus 1 over 2. Does that make sense? Well, yeah, it doesn't matter which way you prefer. I prefer the first way. Now remember, e and natural log are inverse to each other. Now what happens if I have this? E to the 2x minus 1 equal to 5? How would I solve this one? What? Okay, so what would you do? What is opposite of that? It'll be fine. How do I get rid of e? What's the inverse of e? ln, right? Now, do I need to raise the power this time? No. Can I just do ln on both sides? You can do ln on both sides. You can square root both sides. You can do a lot of things on both sides. So e to the 2x minus 1 equal to ln of 5. Does that make sense? Then e and ln cancel out, so it'll be 2x minus 1 equal to ln of 5. So it'll be 2x minus 1 equal to ln of 5 plus 1. And then x equal to ln of 5 plus 1 over 2. Does this make sense?
You're doing the first problem,
Mm-hmm.
showing us that, yeah, 2 to the x y and stuff like that, because I wanted to see the ln x plus ln y again.
Here?
Yeah, because I didn't get for the second.
This is B. Okay, so I'm going to show you the next question that you can possibly have. It's going to be log of x plus log of x minus 3 is equal to 1. How do I solve for x here?
Don't you do like log and then x times x plus c?
Yep, this is actually a SAT question. ACT question, sorry. So you combine, you condense into one, right? And what do you do next?
Minus 3x minus 1. That's all for x.
No. What happened to the log? You haven't get rid of log yet.
Wait, did we?
No, there's no log on the other side because you just combine two log into one log. Yep. Remember 10 log 10 of x times x minus 3, they're inverse to each other, is 10 to the 1, right? So that's going to be x squared minus 3x is equal to 10.
Scroll down.
Does that make sense so far? Can I solve this equation? Now put in mind that x minus 5, x plus 2, right? I think. So x equal to 5, x equal to negative 2. Am I done? Am I done? According to my tone, it's probably not done yet, right? Can you tell me why am I not done? Ooh, that's a fancy word. Annie is very, very intelligent. Yes. It's all Kuma. The damn Kuma is cool. All those worksheets and worksheets. A to K, A to Z level. Right? That's the stupidest way to teach math. No offense, but no, that's just the stupidest way. I mean, no. Just worksheet after worksheet after worksheet. I don't know. It just make me hate math if I had to do that. A certain worksheet I understand, but some worksheet I don't. Yeah, extraneous. So which one's extraneous? So which one do you think is an extraneous? Yeah, probably negative, probably not the right one, right? But why though? Because you cannot log a negative number. Try to log a negative number, right? And we're gonna say that's equal to x, right? And there's a 10. So 10 to the which power is equal to negative 2. It doesn't matter which power does that give you negative values. Does that make sense? So it doesn't matter which value that you do, you're not gonna get you negative 2. 10 to the any power does not give you negative 2. Are we okay here? So this is extraneous solutions. Okay, now we finish the pre-calc. Now let's get down to calculus. It turns out calculus is easier. There's only 2 formulas, and the 2 formulas all look like identical to each other. So it's technically it's only 1 formulas, right? So I'm going to show you the first formula. We're going to learn how to take a derivative of natural log functions. And you're like, oh, that's gross. It's actually super easy. 1 over x. Is that hard? You had to memorize this though. Now let's take a derivative of something other than x. We're going to say u. U substitution, right? What happened is not x. What happens is x squared. What happens? 2x. Almost is actually u prime over u, or du over u. Either one is fine. Now, if I take a derivative of 1 over natural log of x, you already know, right? Natural log of x is equal to 1 over x. Now, whatever, if I take a d to the dx of natural log of 2x, what happens if we take a derivative of natural log 2x? What am I going to get?
Between natural log of x and natural log of y. What's the difference?
U. U is anything other than x.
But I mean, in u substitution, we just used u.
Yeah, so you had to do u, right? You had to do this as u, right? U equal to 2x. Does that make sense? What is du? 2, right? So, or u prime is going to be 2, right? So therefore it's 2 over 2x. Does that make sense? That's equal to 1 over x. It's also 1 over x. Wait. Y is derivative natural log of x is 1 over x. Y is derivative natural log of 2x is 1 over x. Can you tell me why? Can you tell me why? What time we get off here? Oh, we have enough time. We have enough time to think. What?
Coefficient.
No. I'm going to show you something cool too. Right? See that we have natural log of x, right? It's right here. And you see that blue line is a derivative graph? Do you see that? And let's change it to 2 and see what happened. The blue line did not change. It didn't even budge. Change it to 3. And change it to A. And let's add a slider to A. But derivative never change. Or it's, if it's a negative, right? If it's negative, that because it's negative, you have to go the other way. But if it's just a positive, that's just positive, like just say 0 to 10. I totally failed that one. But you guys gonna pretend that you didn't see it. And it's like, whoa, they're all the same, right? But why is derivative of natural log 2x the same thing's derivative of natural log of x? Do you guys know why?
It's just like I'm thinking of like linear functions where like 2x plus 1 and 2x plus 2 is the same thing.
Because it'll always be log e, right? Because that's what ln is. Log base e. No?
Ani might have gone to some point with that. What Ani says? I don't know what Ani says. What Ani say?
I said that like even if you like y equals x plus b, even though b changes, the m does not change. So is it something similar to that? I just
Probably had the like ideas there. So it turns out it's very easy. ln of 2x equal to what? ln of 2 plus ln of x. What happened if you take a derivative of ln of 2 plus ln of x? You're like, I don't get it. I don't get it. Yeah, this has become 0. So ln of 2 or 3 or 4, it's just a vertical shift of the graph. Do you see that graph goes straight up and down? And derivatives stay the same. Now today we're going to teach you how to, so you know how to take a derivative, right? Natural log of 2x, you just say u equal to 2x, du equal to 2, so it's equal to d to the dx is going to be 2 over 2x. Does that make sense? Is that hard? Pretty easy, right? I told you this is actually easier than pre-calculus. Pre-calculus has a lot more rules. This is like so easy compared to that. So remember, you do algebra first, right? Why? Why we do algebra? Because this, if I do algebra, I understand it. I don't even need to do U substitution at all. But it doesn't work always like this. But in this case, I don't need to do anything else. So that's cool thing about this is this. Hey, I'm going to ask you to take a derivative of this one. Remember to do algebra first, okay? How do I do algebra first? How do I expand it? What did we do yesterday if we saw a radical yesterday? Oh, yeah, why not? Did we do calculus? Nope. Now, can I do the u prime over u situation? Can I say u equal to what? du is what? 2x, negative, right? So 1/2 negative 2x over 1 minus x squared. So 2 cancel out, negative 1 over 1 minus x squared. Is this hard? Is this hard? Which part you don't understand?
So the 1/2.
I just put it in front.
Because then the natural law doesn't apply to that.
Yeah, because it's always been that way. That 1/2, that's how you do the thing yesterday. What happened yesterday? You have natural log of x to the square root. That's going to be negative x to the 1/2. That's because I 1/2 ln of x. That's what you did yesterday. You didn't do derivative. You did derivative today. Okay, so I'm going to ask you to take a derivative of this one. You got 2 minutes. I'll go over it in 2 minutes before I fall asleep.
Could you explain the last problem?
Okay, yeah. Do you understand? That's 1/2 power. Do you understand I can move 1/2 in the front? Remember, you take a derivative 1/2 of x. Do I do anything with 1/2? I just take a derivative of x becomes 1. Right? So what happens is I'm just going to take a derivative of this. Well, derivative of natural log of something is u prime over u. So it'll be derivative of that over, which is -2x over 1 minus x squared. And the 2 cancel out on the other side. So it'd be -1 over 1 minus x squared. I can't fall asleep for a while. I hate moving. I've been moving since 5 o'clock this morning. And my wife doesn't want to throw away anything. Is that Asian thing? Yeah.
Probably, yeah.
They keep everything. They think everything can be used someday, somehow, somewhere.
Oh yeah, my grandpa's house, we have like this big closet, and we don't want to throw away anything. We have like a playground back there too. We have like everything. We don't want to throw it away.
Do you guys take a derivative of this one? You got 1 more minute. All right, I'm going to start. I'm going to expand that. ln of 2 minus x squared minus ln of 4 plus x to the 4th power. Does that make sense? 1/2 ln of 2 minus x squared. Does that make sense? And then it's u prime over u, right? Can I do it in my head? Of course. Can 2 cancel out? Yep. Done.
Yeah, it's like, what would make you?
You should do them separately. U prime over u. That's it. That's the only thing I'm teaching today. One concept. Is that hard?
I give up.
She'd say give up.
Ultimately back. Is she? She is. See you later on. Hello. Oh. Are you okay with that coming?
Huh?
Are you okay with that coming after school today?
Of course not.
Oh, okay. Well, you said you were tired, so I was like,
Oh no, I'm tired, but I'm always here for a student.
I'm sitting in the corner right there. In the corner?
And Jim,
What's up?
what is that? Is that Dial God, the Pokemon God of time?
Strong style.
I know what that is.
It's a big arcane. Big in yellow.
Oh, yeah, I see it. It's just very yellow. My God.
And it's also like a
And,
history
yeah,
reading.
yeah.
It is necrozma.
He killed my freaking dial.
And it's sure like I can.
Like necrozma, but it gets destroyed by.
Second
Well, yeah, and you can sleep with
well, no, that is now the one.
Keep this one. Keep this one.
Did you?
Yeah, because no, they all could die, so that he's on his second shot.
I only have legendary Pokemon and a Garchomp on me right now. It's because I'm doing like the final game missions. Dude, how did he hit me? I was behind it.
She kicked back.
Wait, there's hope.
Yeah. So when that's done,
yeah,
like after you do
individual
like,
play.
these things at them. I know
Yeah, you play Wordle.
I'm talking about like.
What?
It's gonna
Oh
jump.
yeah, if you guys pay too much, then you die.
Yeah, I heard New York Times bought it.
What?
The New York Times bought
No way New York Times bought it.
Yeah, it did.
Well, getting knocked out isn't that
They're
bad.
gonna be
But you
very
do
long.
lose some items.
Yeah, you lose some items.
You play it though?
It's a engine.
Am I in trouble?
No.
Yeah,
Oh.
you are.
Should you be?
I don't know.
Yeah, you should.
I jumped the fence earlier. I don't know if I get in trouble for that.
I didn't see it.
I'm in a
Did you
Pokemon
happen-
battle in
Huh?
real life.
The kids that threw the soap dispenser in the toilet. Did
Yeah.
you
It's
actually
a
see
bag of
the kid?
No, I didn't see him throw it, but I see him walk out
I'm
before me. But obviously, he was there for a while.
Right. You,
But,
you
uh,
remember what he was
Oh,
wearing?
there it is.
So he's a
Yeah, are you supposed to?
white, blackish, and a black mask.
Down to 2 and
Okay.
And it's right after I go in the bathroom, so you probably see the angle for going to the bathroom.
Yeah, yeah.
And there was probably 2 students walk out.
Yeah.
There was a darker skinned kid. It's not him. He was using a smaller bathroom.
But a kind of a bigger guy.
Yeah, it's kind of like
Okay.
stucky. And I don't know if he did it. Maybe he just go in to use a mirror. But that's the kid you guys want to talk to.
Mm-hmm.
Yeah, I don't know why they keep on doing
find
this shit.
Well, I don't know.
I mean, it's like, this is so stupid.
I was trying to find it. Like, I have the app. And it's just, which is just pointless.
I don't know what's wrong with this generation. It's like, this generation thing.
They told me it was something out.
It's actually not very hard to
Yeah. I got him on the camera.
be attacked.
But it's not a black kid.
Okay.
It's it kind of Hispanic looking. He wear a mask all the way to here, show his nose, and that's my impression. It's kind of stuck. So
Oh, and like, so we were
yeah,
at the beginning of 4:30. Except for the.
I went to use a restroom. Actually, that kid probably the. It's after the black. Oh, it's before the black kid walk out.
But you're the baby.
No.
Sheila. Sheila. Yeah. Did you like the math competition?
Did I what?
Did you enjoy it?
Yeah, it was like I studied for the problems, so I already knew kind of what was there. So then I guess I liked it. It was fine.
If
You're like,
what you want to go to another one?
Yeah.
but like, I'll take
Unfortunately, next one's gonna be the state, and they're expensive.
Oh, so it's gonna be like the whole state.
Yeah, no state competition. It's gonna be expensive, but it's like 3 days.
Oh, it's 3 days. Okay.
But they're expensive.
Like how expensive?
I don't know, like $200-300 per person because 3 days, and they are like designed for you to stay in a hotel. But although even hotel is like 5 minutes from here, which is so stupid.
Yeah.
Which is so stupid.
I mean, like, I would only pay that money if I knew that I'd get most of them right. Like if I knew that, like, if I studied a lot for it.
I don't think you're gonna get most of them right. Have you seen the ranking?
Like if I saw the ranking for this one. There was like so many people got all of them right, and like it was all beautiful.
Yeah, it's all beautiful.
Yeah.
So there's no way you're gonna be it.
So,
There's
yeah.
no freaking way.
Yeah, I'd only do it if I was like.
You're gonna be all the way up there.
If I was like first, second, or third. Like, but obviously.
No,
you have to get perfect scores.
No, there's no chance of that.
Yeah.
I'll be honest with you. It didn't matter how smart you are.
Yeah.
It didn't matter. They just like robots. They do tests for fun.
I don't even do it.
That's pretty sad.
Yeah.
No, I don't want to do that. I do like the competition part of
Yeah.
it.
So I don't know if I'd do it. Like just because I'd like be paying that money, but I wouldn't even like get that high. Like.
But would you
I do
be
have a
interested
big-
to practice the team test?
Yeah, like practicing. Yeah, and then also the one that we did, like the regional ones, are $5 to $10, and then you just like do it for one day.
Yeah, there's a $10 one, but it's right now the next. So the next one is what's Orlando Science? What's a Science Olympiad competition?
Olympiads, like what?
Yeah, what?
It's at the end of February. Like I think I don't know the exact day, but it's at the end of February.
You guys should be take out a homework and check your answers. And Maria, make sure you read a direction, Maria.
Okay, that's why. No, yeah, that's
Yeah, the next one is actually February 12th, this Saturday. But it's in St. Augustine.
Oh. Okay.
And in order to go, I need to turn in the money. Like, I need to turn in the late fee too, because it's late to register. So, or either St. Augustine. St. Augustine actually would be a nice place to go.
Yeah. I think so.
I will go to St. Augustine. It's nice. It's nice to walk around in St. Augustine actually. And next one, and this one, the same one is in Tampa. Tampa is nice too. We went to Tampa and we snuck in the aquarium.
Wait, you snuck into the aquarium?
My student did. I didn't do it.
Oh,
I snuck in for free.
but that's cool.
And so next one's February 26th. March 5th, but they are pretty far. They are like, it's almost stupid far. Like Dunbar's in Fort Myers. Cypress Bay is almost Miami. So
So that was like the only one, like the one we just did that's like right here.
yeah, they usually have two in here, but the Sanford High School, Seminole High School quit. The teacher quit. So.
Oh. I didn't know that. Okay, I mean, I could do like one of the St. Augustine one is fine. Or like one of the far ones is fine. But I don't think I'm gonna do the state one.
That's fine. I just want to know. But would you want to be practicing at the school?
Oh, okay, yeah, I can still do like practice problems.
No, like practice as team questions.
Oh, like as a team practice. Okay.
So I don't want to do well this year because we don't have too much option.
You don't
But I want to
well?
do well next week.
Wait, You don't want to do Will this year?
I know we cannot do well this year because
Why?
we don't have the ability to finish anything.
Oh, okay.
But next year you guys will know the stuff. already.
Okay. That makes sense.
Yeah.
Okay.
All right, I'll see you.
All right, thank you.
Okay, shh. You should be checking, guys. You should be checking answer with each other.
Number one.
Number one.
For number one, I got 0.
Oh, ow.
Okay, number one.
Yeah.
I have 2. No, because the one, 5, something, 25 what equals 5, and that's 1/2. 3 times 1/2 is 3 zeros. No, what did I get, right? Okay, 25.
I feel like substituting the number.
Well, you didn't have
Like the exponential?
Yeah.
Is 3 log x.
No.
No, it's
I got 3.
Why is it 3?
This? Like
Can you go over
whatever and it cancels out. It's the same thing.
1/3 log x minus
Like, it's just like, it's
64.
log x.
You did it separately, yeah, 64.
But the thing is, if I go to 14, how do I know that? Log x plus 4.
So, you know that 4 is, so what do you?
So it's kind of, because 1/2. I put it in yeah, because
Then it's 4, 1/2 x equals 8.
So, how do you think about it? So 1 would be 3 times 4. So how would you get?
Oh, it's just 2 to the third. 4 is 8. Yeah, 7 to the third. This could be 22. 22x. And then it's 2x equals 2x.
You just do carried into the 5. Oh my god.
I can't do math. I just can't do regular math. Alright, so now it's so that's 4 times.
Yeah, I forgot to tell you, but okay. You know how Xavier like texted in the WhatsApp group chat? Margot was like the leader, or like a great leader. Will was kind of mad about that because he didn't think that she was. Like she was like, she did nothing, and like you need to let him know that like we did, like we were the leaders. But don't tell him that I told you this because he wanted me to tell you that, like, more emphasizing like him and like yeah, he did like help and stuff, but also like I don't want like I don't know. Yeah, that's what he just said to tell you. But
I don't. Well, here's the
I don't know
thing.
if it's that big of a deal, but he told me to tell you. So like,
But here's the thing. Like sometimes the good people who are good at math usually is like look Luke will not be a good leader. He's a good
Yeah.
math person. He's a good math person. And maybe I don't know. I wasn't there to tell, so I don't know. I mean, just but it doesn't matter. I don't know why.
I don't know. He was he was mad
Will
about
sucks too.
Well, because he was like,
Will is not that good either. I mean, he had potential.
yeah.
He had potential to be very very good. Like, but he doesn't even use half his potential.
Yeah.
That's the problem I'm upset about.
Yeah, but he was upset about that because he was like, Xavier was just like, I don't know, because he was like, Xavier was like freaking out the whole time. I don't know. He just told me to tell you that it was like us.
Why does it matter?
That's what I asked. I don't know. I think it's like,
That doesn't really matter.
I don't know. It's like it's done with, so I don't.
It's whatever. No one cares. I don't
tell
care.
him that I told you this because he was like, tell him that it was like us actually. But I don't want to like say that and be like, no, it wasn't her.
Well, it doesn't really matter. Like I say, it does. You guys do as a team. I mean, not it's not one person's accomplishment. It's not just you two. Everything is always going to be contributed by a team, so it doesn't matter who is it. Marco has a very high ability actually. You guys just don't see it because she does BC directly. She's only
she's in BC. Like,
she's only one person. She never did AB. She just did BC directly in 1 year course. It's a very difficult to do.
like she did all the parts that we didn't know how to do. I thought she did them like fine, but I think he meant with, like the AB stuff. I don't really know what he's saying.
AB stuff she's not very good because we were very fast.
Yeah,
we were just like
one semester.
we're just really fast to go through it, so it doesn't really reflect her ability. If she's taking AB, she would destroy everybody.
Yeah.
Just by herself on a thing, she was so perfect at everything. Like everything she does, she's really perfect at it. Now, we'll consider that she's taking 2 years at 1 year course. Now it doesn't really matter. It doesn't make any big difference. Now Xavier is different. Xavier and you guys are different. Xavier is not gonna be able to outthink the questions, but Xavier does putting a lot more effort than Will can ever do.
Yeah.
I mean that's a fundamental truth.
If you put in that effort though, like, I don't know.
Xavier doesn't have the thinking yet. I mean, I'm not saying, and he knows that. I told him before. I says you think linearly. You don't think in the all directions. So if I give him a new question, he'll never know how to do it. He'll never know how to start it. But Will can.
Yeah, like.
And so Will is really good at thinking all abilities. But Will is not the best ability at singing. Will is probably not even close to be top 15 student I know. Yeah, so he's probably the best one this school has to offer in thinking skill wise.
Yeah.
Besides Luke and Will is definitely out of the range of the things. Luke will be probably number 5 on my list, but
Like ever?
for 10 years I mean.
Oh.
The best I have in teaching Leo. The one when the MIT, she can do a team problem by herself.
Wow.
Like I have seen her before. She said, "Oh, okay." I gave him 2 minutes and she did it.
In 2 minutes? Not even each part.
She did it all by herself. I mean, it was really hard integral questions, but she did. I mean, you can do it. You can too. You have that ability as well. But it's just it's not.
I want to know, like which way do you think I think more like I know I'm good at algebra and stuff, but then what about like the other perspective, like because I don't know.
To be able to think out of the box, you have. If I were to rate you out of 100, I think.
Like, give me the honest answer.
I think Will is probably 70. And you're probably 16.
Okay.
To think outside the box, to be able to think outside the box of the range that you can go to. But those are not, they are kind of born with it to think a lot of things critically. Joshua has a little bit of ability. I don't know if Joshua is ahead of you or not, but Joshua also has the ability to think differently.
I think we're the same.
You think a lot of time you go with brute force. Like if you see, you can brute force through a problem, and that require perseverance. That require things that go through different things. But in the most cases, you gotta. I'll give you some outing questions. I'll show you in a second.
Oh, this is
No, I did. It's not. I kid you not. Me and him had. We had it ready. We're like I posted on the fourth too. We're gonna hit the fourth today.
Yeah, try to figure out this one.
Wait, am I allowed to have like paper?
You can take a picture of it.
I have my phone.
We just kept walking. Go back and like less than percent. Miss Dan, can we start the lesson?
Yeah, we are. It's just shit I keep on bothering me. I don't know.
Come on, Eva.
Sir, I heard you compliment me a lot.
You were like, Will is so good at this. Will is so good at that.
The ugly Will. Sorry.
I'll take a picture of it. Wait, this is the ugly one?
All right, so shh. All right, sorry. One of the question, a lot of confusion was number 11, and number 11 is 5/4 log of x minus half log of z.
Wait, which one?
Number 3, 11.
Oh.
It's a 5/4 log of x. 5/4 log of x. Minus half log of z.
Oh, it's long.
Yeah.
Where?
So in the beginning, you know, it's like 4/4.
That's
So you just have to add.
Is it?
Yeah, I wouldn't even have thought to do that.
So that one is a little bit harder. Shh. And also, a lot of people did bad on your FRQ. You need to come back after school. So you guys did pretty well on the Riemann sum page, but just this back page, it's pretty gross. It's like, 1 out of 12, 2 out of 12. That doesn't.
It's better than a 0.
True.
That is a way to look at it.
Yeah, after reading yesterday's chat, kind of worried about your mental health ish.
I was trying to watch YouTube on my phone and it was like WhatsApp every instant.
Mute that chat. There's too many messages.
And then I do the next one.
But it's actually the safe thing important.
Maria basically had mental breakdown because she did all the questions. I was like, what the hell is this? Literally, Maria, you need to stop. All right. So yes, we're gonna talk about some other thing. Sorry, we're gonna talk about a couple things. We're gonna talk about why they are what is log, right? I remember first year I taught algebra 2. I don't know what I'm doing. So a student after a week I'm teaching log, and then like one student just asked me, it's like, hey, Mr. I have a stupid question to ask. And she just says, I forgot her name actually. She asked me, she's like, what is log? And I'm like, shit, I don't know. No. You have to understand. A lot of time, first year teaching is probably the hardest because you don't know the idea behind everything in details. So she asked me that question. And I was like, shit, I really don't know. But I didn't tell her that. So instead of telling her that I don't know, I just say, man, why are you so dumb? I already teach you a week and you still don't know. What is it? So no, I didn't say that, but I sounded like that way. Okay, so I sounded that way. So the idea is, and I feel really bad. Like I really like after that student, I feel like I need to redeem myself. I need to make up for her. Because I think the first year teacher, you don't want it to show like you're weak. You cannot show like, because the kids will literally step over you if you do that. So you have to show them that you're strong. So I kind of like did it in a bad way, and I do think like I owe her apology if I ever see her again, of course, but probably not. Yeah. No, she's an A student. She's fine. She knows what she's doing. So it's not a big deal. So anyway, I want to explain. I want to redeem myself, which was, I wish I remember her name, but it's for her. It's not for anything else. So this thing is y equal to 2 to the x is exponential function, and looks like it's like going up like e to the x. Okay, so I'm gonna show you that this is 3 different properties that you know of. We just teach. So ln of x minus ln of y equal to ln of x over y, and ln of x to the y here is equal to ln of x to the y. And this is actually super important mathematically, because this is the only reason that you can bring the power down. Okay, so the last one, of course, is called changing base. So if log of b of m is equal to natural log of m over natural log of b. So what that's saying is, I want to show you that what is log? Log are the inverse of exponential functions. Inverse of exponential function. That's probably the best definition to give a student. And I'm going to show you how things work. So remember how to find inverse function, like tan inverse, right? Tan inverse and tan, they are inverse to each other. Square root and square, they are inverse to each other. Okay, so if I change this x equal to 2 to the y, because I'm finding inverse function, which is swap the x, y value. But if you realize y is in the numerator, it's an exponent, you cannot isolate a y until you do what? How do you isolate that y by itself? What?
Use the logarithm?
How do you use a logarithm?
I don't want to think about it. You can like convert the form. You can.
Oh no, you don't want to convert a form right now. My question is, how do I isolate the y by itself if y is an exponent?
You make the base the same.
No, Jordan.
The log of 2 on both sides.
Well, not log 2 on both sides, but log on both sides, right? So not any log. I'm going to use natural log. So now, if you see that this is y is in the front, does that make sense? And then can I isolate that? And due to this property here, changing base here, can I change it, says y equal to log 2 of x. So that means f inverse of x. So they are inverse of exponential. And if you something that inverse each other, they do cancel out. So for example, 10 inverse of 10 of x, that's just equal to x. It's actually definition of inverse function. If you do inverse of the original function, then you're gonna get back to x. And that's the way it is. So what happened is, one of your question, I think a lot of people asked this question yesterday on the group chat, was what's b log a b? I don't know, it's 3 or something like that, right? So if you realize this b is exponential to log b, but b to exponential log b is the inverse of exponential function. So therefore, those two cancel out directly, becomes 1 times 3, that's equal to 1. Oh, sorry, 1 times 3 is 3. I'm a dumbass. Does that make sense? Okay, so that log b log b will cancel out because they are inverse to each other. Okay, Anthony, put your phone away. Huh? Oh. Okay, so does that make sense? Now, with that being said, we're going to go through how to solve some equation. So some equation that's a easier one will be like a natural log of 2x minus 1 equal to 5. How do I solve for x here? Sheila? Why do you do that? Right. Remember, natural log is what? Log base of e, right? So can I raise the power of e? Right? And since we know log, Asim, pay attention. We know log is natural. We know natural log is log base e. So we know that is equal to e to the 5. And now this one is going to be ln of 2x minus 1. But we know this part is log of e. So due to this property here, this is one of the property, b log b situation, e log of e, they will cancel out perfectly. 2x minus 1 e to the 5. And then 2x equal to e to the 5 plus 1. And x equal to e to the 5 plus 1 over 2. Okay? Is that confusing or no? It's not confusing, makes sense?
What would happen if you had like
And let's use like the dumb way that we did yesterday, and that's okay. Actually not the dumb way, it's just more like I don't really prefer it, but it's actually one way to solve a problem. Now, if I rewrite that natural log to log e, can I draw a heart? So e to the 5 equal to 2x minus 1. And some people's gonna say this is faster. Now for me, it's just changing the format. Yeah, it's good. But I don't prefer this way, but it's fine. If you show this way, it's gonna be the same answer. And that's gonna be fundamentally. So for me, I prefer to use something to get rid of inverse functions. Now, if you do it this way, it's not bad. It's not dumb. Sorry, I'll take that back. It's just another way to do a problem. Okay. Yes. The log, it just convert to exponential form because you change it from log format to exponential format. Now the second situation can happen is like this. What if you have e to the 2x minus 1 equal to 5? Now instead of natural log of 2x minus 1, now it's e to the 2x minus 1. So what do? How do you get x by itself? Well, you're just stretching.
Yeah.
Anthony?
You take the natural log of it?
Yep, you do the inverse, but you don't do the power because they are the same level. So be natural log and natural log both sides, and then you're going to have e to the 2x minus 1 and the 5. So now this one cancel out, 2x minus 1 equal to ln of 5. Does that make sense? And 2x equal to ln of 5 minus 1 over 2 plus 1. Thank you. So today's homework, I'm going to give you a test I give out to pre-cal student about all the logarithms. And you got to figure out how to do all the things. And also some calculus. Calculus is actually easier. It's way easier. Okay. But we're going to talk about one more question that might affect your homework, which is I'm going to give you the test. So it's going to be log of x plus log of x minus 3 is equal to 1. And we say, hey, solving for x. There's two problems can occur here. First is how to do them. Second is recognize what is the right answer. I'm basically teaching all the logarithm in 1 or 2 days. So you guys gonna have to catch up because we're not supposed to do this. You're supposed to learn this in pre-cal. What do you do first step? Condense. Thank you. I love the word.
Oh, I hate using proper terminology in SCA.
I'm sorry.
Can you not say?
Who say condense?
Why do you say condense? Smart?
Someone smart. Which one is the smart one? Who's Will?
Yeah.
Oh no.
I said combined.
Wow. You tell me that.
All right. So now you can do this. So that's gonna be x squared minus 3x, and then let's log. And what do you do next?
Then you could put both sides.
Put what to both sides?
You could do e to both sides.
No. Huh?
I was gonna say e.
No, not e.
Sorry, I take it back.
Jake? No. 10. Good job. I know, because I'm gonna give you hard questions. Easy question, I won't call you. So can I do 10 because that's a common log, right? That's a log doesn't have anything, right? So this pretty much cancel out. X squared minus 3x minus 10 equal to 0. X minus 5, x plus 2 equal to 0. X equal to 5, x equal to negative 2. Now, which one's the right answer? And why? But which one's the right answer?
5.
Why 5 is the right answer? Why negative 2 is not the right answer?
I don't want to answer.
Okay, Andrew, go ahead.
I said I don't want to.
You don't want to?
Yes.
Oh yeah, Hung?
You can't have a negative as
Well, yeah, but why? Imagine that if I have a log. Okay, go ahead, Sheila. You want to answer this one?
Now I can think of my answer because if you have log of negative 2, then 10 to 10 to what will equal negative, like you can't have it's like because log is 10, so then 10 to the what will be negative 2.
Exactly. So if you have like this, right, it's equal to some type of value that we don't know about. So 10 to the what value is equal to negative 2? It's not possible because 10 to any power does not make it negative value. 10 to any power is going to be, 10 to a negative 2 power is going to be 1 over 100. 10 to the 2 power is going to be 100. But how do you get negative 2? I mean, getting 2 is possible, by the way. Getting 2 is possible, by the way. So 10 to the x equal to 2. This is possible. But 10 to the negative 2 is not possible. This one is actually pretty cool question, by the way. You can actually natural log both sides, right? And then you can say x equal to natural log of 2 over natural log of 10. So it's x equal to log 10 of 2. Yeah, that you can do, but you cannot do the other way. You cannot do is -2. It's not possible. Negative number doesn't work. So you can actually find out is a +2, but not -2.
Be 0 or negative.
Yeah, it cannot be 0 or negative. Good. And the second reason, I'm going to tell you why it's the second reason. Remember the natural log graph? Natural log graph and log graph looks the same. The domain of this graph cannot be negative. If it's negative, then it's automatic undefined. So those are all the crash course I'm giving to you for pre-cal. So this answer is called extraneous. That's a big word, but it's not that bad. It's a big word for me. Too many letters for me to spell. Yeah. And
Hey Siri. Extraneous.
yes. Sure. It sounds like the spelling word.
Okay, goal is to get
He was like, he won the spelling bee, right? And he had like no reaction.
Yeah, I feel so sad for those kids that they have no life. They memorize dictionary.
My cousin won the spelling bee.
I'm sorry, that's sad. You,
Yes, babe. Oh,
she won a national spelling bee?
no. But still, she won a spelling bee.
Like in school?
Come on. That doesn't count.
Still, it's a spelling bee.
That doesn't
You
count.
could win.
No,
Exactly.
because
It does count. Yeah, spelling
no, you have no life.
teacher.
So?
Let me talking.
I'm okay with no life.
Okay, so why can't she be okay with no life?
If you call me no life, I'll be like, yeah, that's fine. It's for you, it's an insult, but for me, it's not. Yeah, it's not. So why you offended?
I'm not offended. I'm
You
not
are.
The one that has no life.
She is gaslighting.
I'm offended for my cousin.
Ah. Yeah, but why you offended if you say that's not offensive?
You know? I didn't ask for this. I asked to be called
Armin, yes.
The difference x equals log 20 times 2. Isn't that just log 2?
Which one?
For on the right, but x equals log sub 10 2.
Yeah, that's just log 2. All right, so shh. Calculus.
Oh no.
Calculus. Wait, what time we get off here? Okay, we got some time. So calculus is super easy. Remember calculus, you have to memorize one equation, which is natural log of x. Now you're using your phone. Natural log of 2x. I'm sorry, natural log of u, sorry. Okay, so derivative of natural log of x is super easy. It's just 1 over x. But you have to memorize it. Okay, derivative of natural log of u. What does u mean? U is u substitution. That means anything other than x. It could be sine of x, could be x squared, could be other things. Okay, so what is natural log of u? Well, it's gonna be du over u or u prime over u. Either one is fine. However, you're gonna say, hey, I know math. I take a derivative is 1 over x if I take a derivative of this, right? Now, what is derivative of natural log of natural log of 2x?
2 over x? 2 over x? 1 over 2 over wait, 2 over x?
No, wait. It's
1 over x. 2 over x. 1 over x. That's the
Oh,
1
no,
over x.
that's
It's straight A, right?
I'm right.
So it's 2 over 2x, right? U equal to 2x, du equal to 2, right? So it'll be 2 over 2x. And you're like, shit, it's 1 over x. It's the same thing as before. What in the world is happening to this? Do we just break math?
No, you just gotta use substitute.
Now, I'm going to say this is true, and you're going to tell me why. It turns out the reason is very, very fundamental. Well, they are the same. They are not different.
Yeah, I know.
Yeah, but you talking about that, but why are they this way? Why they are the same?
He's asking why.
Every number you put into the would give you the same value.
Should I give you a clue? No. See, you have no creative thinking.
I know, and I'm good at that.
You could have just. And the thing is, I want to challenge you to be exceptional.
I'm just getting insulted.
I know I enjoy insulting her because it's funny.
It's not funny. I know.
You have such a You have such a interesting response. Yes. Shh. No, but why? Why are they the same? I'm gonna show you something cool too. I'm gonna show you something here might help you, but just like Andrew says, it doesn't matter what number I change to from 0 to 10. Do you see that derivative graphs stay the same?
Oh, it's because it cancels out with the amount over and
That's what I said.
It's easier than that.
because it's a constant.
You're on the right track. You're on the right track. See, the thing is a simple thing. Look at in this world, the best people, even if a best golf player or best baseball player or best everything, is they can do simple things so perfectly. Simple things do so perfectly, and that's why they have become best in the world. It's not because they can do fancy thing perfectly. So this is what you need to understand. So think of it in terms of simple. Yes.
Because the log graph always has like if you go down to like the limit of 0, the slope is always going to be basically vertical, which means it'll be close to infinity. So it'll always come from infinity. And if you go all the way to the right, the slope will always be approaching 0, which means it always has to go to 0 on the derivative.
Yeah, but they should still have some type of deviations. So I'm going to show you why. This is why I say you guys lack of thinking. Here's what I'm going to show you. Natural log of 2x is equal to natural log of 2 plus natural log of x. And what happens if you take a derivative?
Constant.
If you derivative this is equal to 0 plus 1 over x, regardless what happened. So that natural log of that number is actually a vertical shift of the graph. So it does not matter what happened. Okay, so a lot of time you have to understand those detailed fundamentals. If you understand those detailed fundamentals, think things simples, always. So I'm gonna show you. Now start thinking things simple. Which go back to algebra, which is what I did here. It wasn't some complex thinking. It's just go back to simple algebra and think about why that is. So here's the thing. If I have natural log of square root 1 minus x squared, and I want to take a derivative of this. How do I take a derivative of this?
A product rule.
No. No. Oh, U sub, yeah, but U sub is integrations, but you can do derivative as well. But
We do 1/2. Like I'd expand it. And then
yeah, see now interesting something simple, right?
do
No,
1/2
that's a very simple. I didn't do anything calculus. Now I'm gonna take a derivative, right? So be 1/2. If u equal to 1 minus x squared, du is equal to negative 2x. So be negative 2x over 1 minus x squared. So that 2 cancel out, is to be negative x over 1 minus x squared, dy dx. Easy? Think simple. Go back, always think of algebra. Because before you take derivative, make sure, do you see something that you can do in algebra first? Always think of that first, right? Before you jump in to do something. Start things simple. Now, you might feel like I criticize you, is because I want you to guys always go back to fundamental. You want to be best golfer, you better stand up straight. You cannot have a hunchback. If you want a good pitcher, can you have a hunchback like this? No, you have to make sure your basic posture is perfect. Not only good, they want it perfect. So go back to basic all the time. So how would I take a derivative of this? Natural log of square root of 1 minus 3x squared over x plus 4 to the 5th power. How do I take a derivative of this? Why do we do yesterday's homework?
Get our basics down.
Yep. So now the basic is covered. You should be able to do this one. Try it, do it. How much time I have? Huh?
3 minutes.
3 minutes? Okay, we'll give you 1 minute to do it.
Take that into the front. I don't know.
Yeah, 1 more minute. According to yesterday, we say we can split this to 1/2 natural log of 1 minus 3x squared. Does that make sense? Yeah. Minus 5 ln of x plus 4. And now you're going to take a derivative. It's 1/2 times negative 6x over 1 minus 3x squared. Minus 5 over 1 times x plus 4. You're done. Negative 3x over 1 minus 3x squared. Minus 5 over x plus 4. And you don't need to go further. Algebra, so the hardest part is not calculus. Calculus is easy, it's cake. Anybody can learn calculus. You can go a middle schooler says, I'll teach you how to do calculus, how to take a derivative of x squared. They'll be like, well, how come the calculus is easier than the algebra 2?
Oh, that's because it's all about your mind. Your mind muscle connection.
He just wants some smart.
Oh, dogging on Aiden. Oh, we like that Marvel legit.
How long is the homework?
Huh?
How long is the homework?
About. Why you ask me like question that's not relevant? Like,
I want to know. Time
like,
management.
like, how many questions on the test? Does it matter?
Yeah, it does matter.
It doesn't matter.
It does.
You go in there, look at the test, you see how many questions in the
It's
test.
a simple question. You're making it such a big deal.
Damn, boy, you get
I don't know.
Yeah, it's your homework. How do you not get it?
Yeah. Depend on my mood. For now, I'm gonna say depend on my mood. How many questions on the test? Depend on my mood. How many questions on homework? Depend on my mood. Bye, Miriam. Huh? I don't know. She'd like to pick a fight. That she's not gonna win, but she wanna pick a fight with me. That's your cousin, right?
Were you surprised when you found out?
Huh?
Were you surprised when you found out?
Yeah. I was surprised.
That's what a lot of people said.
Wait, was on mom's side or dad's side? Your mom's side? So she, her mom is, wait, her dad.
Her mom is my mom's sister.
Oh, okay. So you guys are very close.
Yeah, it's only 5 minutes away. So like, yeah.
Oh, okay. No.
No.
So I know your favorite student. Don't lie.
Okay, Will's my favorite student. Happy?
Wait.
Yeah, I haven't.
No. I'm your best AV student.
Best AV student. Well, according to score, yes.
Yeah.
What's up, man?
You have the quiz. Start then.
Huh?
You have the quiz.
Give me a second. What happened? You okay? You look tired. You just take a nap, didn't you?
No.
I feel like you just take a nap.
No.
No?
It's because I didn't take it. You have the quiz now?
Yeah.
Alright.
Hello there.
Hey.
Do you enjoy that hello? Which is this? Okay.
Mazel. Caribbean came off your.
I'm pretty sure Katie did that.
The Caribbean.
That looks like her
what do you think?
Yeah, that doesn't look like Kate.
Yeah, I texted Paige this morning. I was like, "Are you gonna love it today?" And she's like, "It just says your name."
No, it wasn't Katie. Hey, it wasn't Katie because we left together.
1 minute per
She
day.
could have done it before.
I was literally with her.
That was good. Stop. Fishing. I don't know anybody else.
Yeah.
Over there. No, not that one. You already taken that one. Yeah. What is Q? Who is Q? That's all like who? Oh, look who is back. You
I did my homework yesterday too.
you did? How's your wisdom teeth?
It was not good. I was in home for 4 days. But I'm fine now, obviously.
Yeah.
Oh, it's not good either. No, well, it's kind of nice, obviously. And then it's also the doctor's like, "Try to catch it, right?" Like, yeah. I drink it afterwards. And help after.
Well, we all know Jake, so I mean,
All right, so where's Joe? Yeah, Derek, this that's the test from before.
Which one?
So you're about to fail the second one.
this one's a non-calculator.
This is the first one?
Yeah.
Oh, yeah. That, right? Yeah. I was like, oh, why did I fix that so quickly? People use
How we, he's gonna fold it to really, really tiny, small thing.
Literally, whenever you watch one of your videos, and I just see all the icons on the bottom of your screen. I always check the mail icon to see how much is on it.
I don't know what you're talking about.
Whenever I watch your videos on YouTube, I always look at your mail icon to see how much you have now. Look at your mail icon, and you have 117,000 right now.
Yeah, 117,630 right now. Okay, so yeah. So when you gonna take that test? Tomorrow. I already decided. You had to take both part on Thursday.
There's 2 parts?
Yep.
What?
There's a calculated part and there's the non-calculated part.
Everybody took 2 parts?
Yep. They take on Monday.
Okay. Alright, yeah, can I do Thursday? Feel on Thursday?
You're gonna fail today or tomorrow. That's what you say on that test.
Last test.
Hey, I'm not gonna be here Friday. Oh, I already told you. My
Yeah, you already told me Friday.
Yeah, sorry.
I'll record it.
Thank you.
You don't have tests on this Friday, so you don't need to worry.
Thank you so much.
Yeah, I'm not gonna be there either.
Why?
The wrestling. I went to two at my last tournament. I was one match for complete.
What the hell are you doing? You're supposed to be reading it after my class.
Why'd you throw it?
You can talk.
Is that Kama Krista?
Yeah.
Oh, that's an actually good book.
I started reading it like 2 years ago, and I made it half.
Only
And
halfway?
then I stopped reading.
I would have read through the whole thing now. I read the whole thing in like 2 days.
But I don't remember much of what I read, so I have to reread it.
It's about his revenge. It's actually a really good book. How do you stop and have that book? That's the book that you should not start halfway.
Like, no. I read it to the.
You actually Google Translate things.
No, I've said this before.
I didn't start halfway. I read to this point and I stopped.
Yeah, I don't think you should stop halfway on that book. That book you cannot stop halfway. You had to go all the way through. One of the best book of all time.
I prefer Life of Pi.
No,
I really like Thousand Fun and
All right, so shh. What we're gonna do is homework. How'd you doing on phone homework? Derek, you really need to start doing the homework.
I did all the homework from last week.
Huh?
I did all the homework from the last week.
Oh, really? Good.
I didn't do a lot. I do know that. Make a log, whatever, from the tree, and then something. It's pretty. It's like a. Stop clouding me. God damn.
Hey, that
All right. So homework questions. You guys should go over what's homework. How to help out each other out. Make sure you go over the question you don't know, and I'll go over the question you don't know. We have a lot of interesting questions today, so I'm gonna kind of record it. Wait, where's my thing?
Are we still working on logarithms today?
Yeah, we're gonna do we're gonna not only do logarithm, we're gonna talk about derivative of logarithm, and I'm gonna give you a log test.
You're giving us a log test? I thought you said we weren't going to have any log tests.
I'm gonna give you a log test as a homework.
You mean like you did with the algebra thing at the beginning of the year?
Hold on, just let me get this thing done. All right, so homework questions. Do you have homework questions? Homework questions? Going once, going twice?
7D.
We never had to go to 7. We only do first 4 questions. All the parts in first 4 questions. For some weird reason, everybody thought.
First 4 pages.
Did I say first 4 pages?
No, you didn't. They supposed to interpret it.
I thought you said first 4 parts in every question.
Yes, Basil. Number 2 plus 6. There's 6 parts. Oh yeah, there is. Wow, that's a very bad counting skill there. Answer is 64. Answer number 4 is 64. Okay, hold on. Let me go do it the other side.
Oh, can you do 2?
Explain number 4 on part 2.
Yeah, you meant that.
Wait, part 2, question 4 was extremely difficult.
Question 4, part 2 is not extremely difficult.
No, sorry, and then it's 0. It's 3.
Question 4, part 2, you just have to write down exponential form.
Question 2, part 4.
Question 2, part 4, that's just, okay, that's just 3.
How do you do that?
I will talk about it later.
Okay.
Wait, can you give us like all of them? Or no?
Can I get your answer? Okay, well, I can try it. I'm going to do it in my head really fast. Number 1 is a 2. 2 is 0. 3 is half. 4th is -3. 5 is 0. 6 is 3. 7 is -1. 8 is -2. 9 is 2.
Yes.
10 is -1/3. Oh no, 1/3.
Yeah.
And I think this one's -3/2 or something like that. -2. Number 2a is 0, 1, and 3, and 3, and 3/2, and 64.
Okay, correct.
Number 3, 1 is going to be 2x, 2 log of x plus log of y. Number 2 is going to be 3 log of x plus 2 log of y minus log of z. Number 3 is going to be 1/2 log of x plus 3/2 log of y minus 4 log of z. 2/3, yeah. I'm sorry. Number 4 is log of x plus log of y plus log of z. Number 5 is log of x minus log of y minus log of z. It's both minus. Number 6 is going to be 2 log of x minus 2 log of y. Number 7 is going to be 1/3 log of x plus 1/3 log of y. Number 8 is log of x plus 1/2 log of z. Number 9 is
Wait, what's it again?
log of x minus plus half log of z. Number 9 is going to be 1/3 log of x minus 1/3 log of y minus 1/3 log of z. Number 10 is 3/4 log of x plus 1/2 log of y minus log of z. Number 11, the work is right here. 5/4 log of x minus half log of z. Number 12, it's 1/2 log of x plus log of y minus log of 4 log of z. They should be very easy. And number 4, just do a hard. Nothing you can do. And 4 and 5 are pretty easy. You don't have to do 5.
No, only up to he said we don't have to do that. Yeah.
Questions?
Actually go through, because like for 16 or not 16, for 6 question 2, the 6 part.
You don't have to do 6 part.
No, sorry, question 2 part 6.
The last one.
Oh, this one? Just you do it separately. You do it this part first, because that's an exponent. So log 4 of 8 is equal to x. That means 4 to the x equal to 8. That means 2 to the 2x equal to 2 to the 3. 2x equal to 3. X equal to 3/2. And 16 to the 3/2 is going to be 64.
Oh, so how does that work?
What?
Like part 4 of that same question.
This one?
Yeah.
Oh, we're going to talk about that.
What's the answer for question? Give me part 11 again.
It's right here on the bottom. It's 5 over 4 log of x minus half log of z.
Oh, congratulations.
What?
They're talking about working it out. He is going to be 27 ways.
All right, can I go on?
He goes, why am I not your background? We're not in a relationship.
You don't need a relationship.
It's okay.
People clowning me again.
Derek does have funny faces. Like it's really funny to like to make fun of him.
Oh, what is it?
I'm glad.
Is today's lesson?
No, we are talking about today's lesson. Yeah, I don't really make sense sometimes.